Máš štěstí, jsi poslední, kdo se na to ptám. Tam ahoj kluci. Rád bych řekl ahoj kluci a holky, ale člověče, koukám jak koukám. A holky tady nejsou. Jedna se přihlásila, teda dneska ráno se omluvila, takže je to smutný, ale sami kluci tak dneska jsou. Já vás tady moc vítám vás u nás v MoroSystems. Jsem moc rád, že jste přišli. Když jsme s klukama přemýšleli, koho bychom přivedli semka do České republiky do MoroSystems, aby to byl někdo zajímavý, tak to rozhodování nebylo moc složitý, protože Spring je prostě technologie, kterou v MoroSystems používáme už strašně dlouho, snad od začátku. Tomáš a Standa by o tom mohli vyprávět s Radkem, jak dlouho to je, už je to řada let. No a samozřejmě, když Spring, tak kdo jiný než Juergen Hoeller. No a když jsem Juergena zval semka do Brna, tak jsem vůbec netušil, že opravdu na to řekne ano a přijede. Ale on to řekl a přijel. So I would like to welcome Juergen.
Okay. Thanks.
I'm very happy you are here with us.
It's my pleasure to be here. Thanks for inviting me. Right? Thanks for organizing this.
Já vím, že jste nepřišli poslouchat mě, ale Juergena, takže I would like to pass the word to Juergen and it's up to you now.
Thanks. All right. Well, welcome from my side. I can guess roughly what you have been saying initially, so it certainly was perfectly all right. Welcome. Glad that we have such a packed room here, but at the same time, this is actually a really convenient setup. It's among the most convenient setups I've ever had the pleasure to talk in, right? With couches and there. I actually have to force myself not to sit down. It looks so convenient. So just in case I do, just bump me and I'll get back up again. The topic for today, it's very obviously is Spring Framework 5. I had the privilege of guiding, this framework through so many periods already. So I've literally co-founded the project back in 2003, and when it was on SourceForge initially, and I've done the release management, served as the release manager for Spring Framework proper ever since the 0.9 release. So just to give you an idea, literally every single Spring Framework release, including all maintenance releases that ever happened, I signed off myself. So I either did them myself or I gave the go signal, right? Made the decision about the backports and the decision when to actually release them. I'm a bit of a control freak in terms of release management, but that's a different subject. So my role is to be the project lead of the Spring Framework project. To just for the common understanding, if we say Spring Framework, we mean github.com/spring-framework, right? The spring-framework project on GitHub is literally the scope of what we're talking about here. Spring is many things these days. It is a quite large portfolio. So there are many portfolio projects around Spring Framework, on top of Spring Framework, such as Spring Data, Spring Boot, Spring Cloud, Spring Security. So all of those have their own project teams and are essentially separate projects. We decided to have this ecosystem of projects instead of just one large team because it just works for us. So the Spring Framework project has about six key committers on it, regular committers on it, not all of them full-time. We are very close to the Spring Boot team, so Spring Framework and Spring Boot are actually very closely co-evolving. But there are other parts of the Spring ecosystem that we have a much looser relationship with, including Spring Cloud, actually. It's not always obvious which projects are very close and which are rather decoupled. That's all very intentional because we want to move all of these things forward, but not necessarily at the same pace. We decided to do Spring Framework 5. Like 2016-ish, right? It's now 2017 in the meantime, but we have a rough idea of when the world needs a new Spring Framework generation. That doesn't necessarily translate to new Spring Webflow versions or even Spring Data versions. So we have a very decoupled release management. We bring it all together in what we call the Spring I/O platform. So this is basically a large dependency management arrangement. So much basically for what we're doing. We're talking about Spring Framework 5. There are many initiatives following in this I/O platform arrangement that we're working towards. I'll get back to this at the very end of the presentation in terms of when to expect which kind of release. All right. Well, so much for the Spring Framework or Spring portfolio coverage, really. A couple of words on myself beyond the obvious that I've been doing this for a long time. And I'm still the framework architect for the Spring Framework 5 generation. I actually have a consulting background. I used to be a consultant originally before Spring, around Spring when we started it. In the meantime, I'm in an engineering position. So I work out of a home office in Upper Austria, in Linz in Upper Austria. And am one of the people that we have in the engineering team exclusively dedicated to a single project. So I basically spend all of my time on Spring Framework proper, except when I'll go out and talk about Spring Framework, right? So I do two things. I develop on Spring Framework, or I talk about Spring Framework. That's pretty much all I'm doing, all day long, all week long, all year long. All right. So, quick question to you. What's the state of the art? It's Spring Framework 4.3 that we released last year. Who's actually actively working with Spring? Here. Okay. Among those, of course, who's working with 4.3 already? All right. Counter check. Who's on an older Spring Framework version at this point still? All right. Well, it's actually a quite fine mix, because we want you to upgrade, right? We want you to be on a reasonably recent. Literally, I'm a pragmatist from deep in my bones, right? So reasonably recent, right? It doesn't have to be the latest, but 4.3 is the current feature release. It's the last feature release, the last 4.x release that we planned in the 4 line. In fact, we weren't even sure whether there would be a 4.3. You know, release management is something rather dynamic. Initially, we only planned for a 4.1 and a 4.2. At some point, we figured that we have a plan for Spring Framework 5 and, JDK 8+, JDK 9, the reactive topics, things where we have to wait for third parties to actually do their thing. So we figured that's a bit of a long gap. So we decided to do an intermediate feature release in the 4 line. 4.3 actually co-evolved with the Spring Framework 5 plan. I tend to see it as a bit of, it's a sort of early backport of features which otherwise would only have ended up in 5.0. So as a 4.x release, it actually lives within the system requirements of the 4 line. So it's JDK 6+, of course, JDK 8 is kind of the reference JDK, but still 6 and 7 compatible. Servlet 2.5+ in terms of runtime requirements, so it even works on in the meantime end-of-life Tomcat 6, and there's still by far not end-of-life to WebSphere 7. So we basically cover the entire Java Enterprise infrastructure landscape out there. And as the last feature release in its line, in its generation, it will enjoy an extended support life. You've seen this with Spring Framework 3.2, I suppose, which had a multi-year support life as the last 3.x release. It only got end of life end of last year. Spring Framework 4.3 is going to enjoy a similarly long support life, at least until 2019, I would argue, as long as there's demand. But there's not going to be a 4.4, and there's not that much going to happen, right? In Spring Framework 4.3 as of like mid this year. Actually, at the moment, there's still a lot happening, but once we have 5.0 GA, 4.3 is going to be in maintenance mode. So to give you an idea of how we go about these things, just 2 examples for features that we chose to bring into the 4.3 line, although they could have been 5.0 only. They are essentially minor refinements. The the central theme of the 4.x line is the annotation-based component model. The composable annotation story, the annotation-based endpoint model, all variants of generics-based injection matching. There were a couple of central themes in 4.x. They were all annotation-related. And there was a Java 8 plus, a Java 8 support theme there, but the rest was annotation-related. So what's actually new here? This little thing. This is a pretty standard annotation-based component in Spring, but the auto-wide annotation in such an obvious single constructor scenario is not being enforced anymore. So we actually, even if you omit the auto-wide annotation, that's why it's commented out. So even if there's no auto-wide annotation on this constructor, the framework is still going to choose that particular constructor because it's the only one. It's very obvious that it's meant to be used for dependency injection. There is no other. Historically, we were rather explicit. We were enforcing the use of explicit annotations in quite a few cases. I actually still recommend explicitly annotating these things if you can. So that's why it's here in commented out form. I would actually have it commented in if I was to manage that code, because of the self-descriptiveness. Now, annotations tell you something about the thing that they're annotating, this particular constructor. Even to the uninitiated, to developers not so familiar with the particular workings of the framework, it becomes a little more obvious that something is happening here and what particularly could be happening here. If there's an annotation has Javadoc, you can click on it and read the Javadoc, right? So it's sort of even telling a little bit more than we see here. It's a type that you can navigate to. Anyway, right? The new thing in 4.3 is you can omit the auto-wide annotation from classes in particular, which otherwise wouldn't have any other annotations. For example, delegate classes with no transactional boundary, maybe explicitly registered, so not even detected in the class path. They might not have a stereotype, they might not have transactional annotations. No other annotations at all, just a need for dependency injection. In an arrangement where other classes, of course, are using annotations. That's the sort of scenario where we're leniently allowing constructors to not have an auto-wide annotation. And the other one is alternative JVM languages. That's actually a theme we're going to rediscover a little bit later. With languages other than Java, it's not always so obvious or so straightforward to actually add annotations to particular members of a class. Or even with Lombok, which isn't really a language, but sort of a dialect of Java, right? Even with the Lombok project, all args constructor, you don't actually have the constructor in your source code, right? You can only annotate what you have in your source code. If the constructor is implicit in this particular language that you're using, then it's a little hard to annotate an implicit, not available thing, right? So that's another reason why the auto-wide is not required anymore. It's kind of the same thing. That's a configuration class, of course, but what's happening here with this particular constructor, that's actually two things. That's the full extent of the feature, right? We consistently support injection constructors on all Spring component classes now, including configuration classes. Historically, that wouldn't work because configuration classes were forced to have a default constructor. They were forced to obtain their dependencies, if they had common dependencies that they wanted to manage in a field, they had to obtain them any other way, through field injection or anything else. As of 4.3, we do support the same flexibility in the constructor arrangement that all other component classes, service classes, repository classes, controller classes already enjoy. That's a consistency argument. Configuration classes are just component classes with a special role. So they should be able to do things that all the other component classes are able to do. And of course, in combination with the previous feature, you don't actually have to mark it as auto-wide, but you can, right? But you don't have to, because in particular for a configuration class, there's in all likelihood only going to be one constructor anyway, a very obvious arrangement. So that's the sort of thing we did, basically fine-tunings in the in the configuration model, in the core container. On a related note, and because it's actually coming up again in another part of this presentation, this is the regular Spring MVC controller model as of 4.2, basically. Everything we're seeing here would have worked in 4.2. We chose to bring a different flavor for the mapping annotations into 4.3. And that's very commonly showing in modern day examples and in Spring 5.0 examples. So the difference between those two is, of course, just in the mapping annotations, right? That's good old request mapping, as has been around since 2.5. These request mappings are super flexible. They can do everything and anything, map to any number of HTTP methods. I mean, that's all great, but actually too flexible for typical REST endpoint mappings almost, and in particular, a little too wordy. In the Java annotation model, the moment that you have more than one attribute for a particular annotation, you have to name the attribute, right? The Java annotation model in the Java language has this shortcut value, single attribute model, but only if there is a single attribute. That's a little unfortunate here. In almost all cases, you're going to have at least two attributes, so you can't shorten it. These variants, get mapping, post mapping, patch mapping, put mapping, and delete mapping, they are designed slightly differently. It's very trivial technically what's actually happening here. They are just composed annotations, meta-annotated with @request mapping. You could build them yourself very easily. It's part of the composable annotation model in Spring. We just chose to ship them out of the box, that's all, right? Almost as a sort of reference for what you can do with composable annotations. But also because they're actually really convenient. In terms of the design decision here, the annotation itself implies the HTTP method, right? In the name, get mapping, post mapping, it's in the name of the annotation. So in terms of attributes, you can, at least in quite a few scenarios, get along with just a single attribute, the path. You can specify consumes and produces conditions and other mapping metadata. But in common cases, a single attribute, no name for the attribute given, right? You could say path equals books ID, but you don't have to. You can just put the string there. So it's significantly shorter for common cases. So that's basically the sort of stuff, a lot more actually, that we brought to 4.3. 4.3 was a really rich feature release. But that's part of the 4.x mindset, the 4.x theme set. The annotation-based component model, the composable annotation story, those are 4.x themes. So based on this idea of completing the annotation-based component model, we brought them into 4.3. And because it's technically actually very straightforward, and it works perfectly well on Java 6 and 7 too, so why not bring it to 4.3 for immediate use in production on all sorts of environments, instead of waiting for 5.0 to bring those things in. So take it for what it is, a sort of early 5.0 backport into 4.3 that's available for almost a year already. So what are we actually doing in 5 then? Well, Spring Framework 5 is a little different in its themes. We intentionally chose very different themes from Spring Framework 4. We of course keep holding on to everything we've been doing before. The annotation-based component model, of course, is being refined a little. It's still very much the first-class common choice. But in order to inspire ourselves, to inspire yourselves, in order to challenge the framework code base and the core framework design decisions a little bit, we bring kind of new elements into the picture. For example, the functional style. We're going to get to that in a deeper fashion. The functional style intentionally makes assumptions about not using annotations, not using reflection, kind of forcing a different usage model onto the framework as a sort of one extreme of a spectrum. We generally are very infrastructure focused here. Infrastructure in quite a few ways, right? We always embrace new JDK generation. So we embrace JDK 9. It's coming in July, hopefully. I'll say a few, not much, but a few words on JDK 9 in just a bit. The module system, everything, we're going to get to that. The Java EE8 release in July brings Servlet 4, brings Beam Validation 2, brings the JSON binding API, all things that we are going to embrace into Spring Framework 5 as well. So new JDK generation, new API generations, at least a few, not many actually. And Kotlin, so just a forward reference, we're going to discuss a little bit about Kotlin in a bit. We are actually strong believers in the Java language. So we always embrace the Java ways of doing things. At the same time, we like to challenge ourselves and we like to be open-minded towards alternative JVM languages. We used to have, well, we still have, a fondness for Groovy. That's pretty well known, I guess, right? Grails being Spring-based and Groovy being used in combination with traditional Spring quite often. Some Groovy-based sample applications out there in Bootland as well. So Groovy was the major JVM language that we focused on as an alternative to the Java language. There's a new kid on the block that we're really interested in, and that's Kotlin. Coming from JetBrains, the makers of IntelliJ IDEA, and actually a really interesting language design and a very ambitious open source project team behind it. That's the two things that we need, right? In order to bring it into our world. I'll say more about that later as well. So the only thing I'm going to single out here before we move on is JUnit 5. Also an inspiration to us, actually coming later than Spring Framework 5 in the meantime. JUnit 5 is in the middle of its milestone phase. But of course, JUnit is pretty much the most popular open source project in the entire Java industry, right? I mean, it's by far the most used library out there. And JUnit 4 already dates back quite a bit, right? It's actually quite old in the meantime. In particular, its fundamental architecture is somewhat old, right? Coming from an earlier period. There really needs to be a revision of the fundamental integration architecture, the whole runner model, the extension model, where everybody chooses to use several JUnit extensions, but it's actually quite hard to combine them. JUnit 5 has a fundamentally different architecture in terms of extending its runtime. That's all great, but it's still in milestone 3, and I don't actually expect it to go final before late this year, so like maybe October-ish, but not earlier. So Spring Framework 5 is going to be there earlier, for sure. But we are going to ship our JUnit 5 support. We're shipping it already in the 5.0 milestones on our end, and we're just going to ship early JUnit 5 support with Spring Framework 5.0. We were involved in the crowdfunding campaign. We actually sponsored JUnit 5 in several ways, so we quite strongly believe that the world needs this. So we were a corporate sponsor, we participate in the crowdfunding, we sponsored some development time. We have an engineer actually in my Spring Framework team. Significant parts of his engineering budget last year went into JUnit 5, and some of this year's budget will go into JUnit 5 as well. We really want that to materialize. All right, well, so much for that really. So external forces that we consider and bring into our world, right? Because none of those is really in our hands, right? JDK 9, the Java E8 specifications, even Kotlin, those are independent projects with an independent mindset and an independent release schedule. But we chose to bring them into Spring Framework 5 because they make up for a really nice overall set of inspirations for us. So let's decompose this a little. And I'll start with JDK 9. So we're going to dive into a few themes that I find particularly important. This is not a complete 5.0 feature overview, of course. It's just main themes that are particularly relevant on, from a strategic perspective, right? I mean, those are themes that are going to be with us for years to come. They are not just a snapshot in time in 2017. They are going to keep us busy, both us and you, I suppose, busy for several years to come at least. So, JDK 9 for a start. And at this point, we're going to do it theme by theme, right? So if there are any questions, in particular around a particular theme, then just feel free to interrupt me, right? If there's any JDK9 related questions, I'm going to ask after this section anyway, but just drop a question my way. It really makes sense to do them while we're talking about that particular thing, right? So I'm going to start with JDK9 in order to get over it. JDK9 is actually a really complex beast, right? Let me summarize it a little, right? This is not the central theme for this evening. JDK9 is always being talked about as the Jigsaw release, bringing the module system to the Java world. The Java Platform Module System, which is actually the official name of Jigsaw. But from my perspective, JDK9 is much more than that. And we are doing ourselves a favor by just ignoring Jigsaw for the time being, right? Basically, if you ever consider a JDK9 upgrade, don't consider Jigsaw first. Consider Jigsaw as a second step, if at all. So the most important part is JDK9 brings a lot of runtime enhancements. It brings compact strings. It brings a revision of the G1 garbage collector. It's internally modularized, so it actually may, at least in some scenarios, bootstrap. The JVM itself may bootstrap faster than before. There are a lot of little refinements that make up for a really nice runtime upgrade, right? Runtime benefits upgrade that you can consume completely transparently. Take an existing Java 8-based application, Java 8-based Spring application, keep it as is, don't even recompile it. Just run it on JDK9, right? And you transparently get a better memory profile at runtime, probably slightly faster startup, but in particular, runtime memory usage, the efficiency of runtime memory usage is significantly better than in JDK 8. So that's great, right? Transparent benefits without us having to do anything other than upgrading the JDK. That's what we want, right? So JDK 9 is going to come in July, they say. I'm actually quite involved in this. So at this point, the JDK team is still working. It's still operating under the assumption that they are going to release at the end of July. I'm personally not convinced they can make that date because there are some really fundamental discussions about Jigsaw still, about Jigsaw default policies. I'm not entirely sure that's going to work. I would love for that to happen, but we already have March. So those discussions shouldn't happen 4 months ahead of a release. The sort of things discussed on the Jigsaw mailing list right now are just mind-boggling. So I'm going to show you a little bit of a Jigsaw impression with Spring on the next slide. But the most important part of my message here is consider the upgrade. There's no point in ignoring JDK 9. We have to embrace it. As a community, as an industry, we have to be willing and able to embrace the latest infrastructure in our world, right? We have to upgrade to JDK 9. And in particular, Oracle's going to make us upgrade anyway. They're going to end the public updates, JDK 8 public updates rather soon. So, I mean, if you want to be on a supported branch of the JDK, better consider the upgrade. Stay in class path mode. As we're going to discuss in just a moment, there's 2 modes of operation in JDK 9, the class path mode and the module path mode. They are literally different modes of bootstrapping. If you stay in class path mode, which is basically what you do by just upgrading the JDK and running your scripts the way you always did them, or running Tomcat or whatever the way you always did them, then you're in class path mode. And you're basically safe. Make sure that you're using the latest versions of the libraries, like the latest Spring Framework 4.3 release even, latest Hibernate releases, and you're going to have a fine, smooth experience. Because all of those open source projects have done their job already. CGlib, Java Assist, all the bytecode generation libraries, they are all JDK 9 compatible already. There were only minor glitches to sort out in class path mode, right? So it's not completely smooth if you just take a really old deployment unit, but as long as you have reasonably recent libraries that you're using, or frameworks and server versions that you're using, you're going to be fine. My recommendation is to just try it, literally. Take the thing that you got, switch Java home or your JDK pointer, do a smoke test. Just start it up and see what happens, right? And in all likelihood, I guarantee you, with the latest versions of in particular in the Spring world, with the latest versions of the libraries and frameworks out there, you're going to have a fine experience. There's always the 1%, right? There may be issues. There always can be issues. But in general, it's going to be a smooth ride. So what is this Jigsaw business then? In particular, what's our recommendation? I see Jigsaw as something, as an opt-in mode of JDK9, right? As something that you choose to opt into. So if you're on JDK9, you can keep using everything in class path mode, Spring Boot in particular, traditional server container arrangements in particular. You're going to have no other choice anyway for those. But if you're building an application from scratch, completely new project, you're free to structure things the way you want them to. You're going to be Spring Framework 5.0 baselined. That's all great, because you can choose to opt into Jigsaw then. You can choose to build your own application modules as JDK9 modules with module info descriptors. You can choose to run them on what the JVM 9 calls module path. This is essentially a runtime module system preserving the boundaries of your structural deployment units. So on the class path, that's not actually happening, right? On the class path, you just drop a lot of jar files onto it. But at runtime, it's literally just a flat, long sequence of directories with class files and resources in them. The JVM doesn't actually retain structural information. So it doesn't know which classes were actually in which jar file. I mean, some class loader may know this, right, in terms of caching resources. But in general, the JVM doesn't really reason about the structure of your deployment units. Jar files are literally archives, like zip files, right? It doesn't make a difference whether it's in a zip file or whether it's an exploded directory. It's basically the same thing to the JDK. Just a long list of class files and resources. In Jigsaw, that's very different. Jigsaw modules are still jar files. So at least for application purposes, they are still jar files. And these jar files, when loaded onto the module path, actually have a runtime representation. There's literally a Java lang reflect module, right? The structural information is not only available to the JDK, but also to the JVM, but also to frameworks and libraries at runtime. So we can reason about the boundaries of particular modules. We know that this particular jar file had that particular module name, it had these packages inside, and it has certain metadata at the module level. And it has enforced visibility boundaries at the module level. That second part is probably the most important one, because that's the number one thing you're going to bump into. The moment that you choose to use Jigsaw, that you opt into Jigsaw, you're going to have to live with strict runtime enforced visibility boundaries. A module is only exporting what you declare to be exported. If it's not exported, if it's not opened up, that's actually two different things in Jigsaw, then other modules and other frameworks and libraries are unable to see those pieces in your module. You can actually hide things. You can literally conceal parts of your module from being seen by any other module in the system. By default, of course, everything's exported, but the whole point of a module system is that you're going to reason about some packages, some facades that you're exporting, and a lot of internals that you're not exporting. That's where it becomes a little fishy. What's internal, right? Are implementation classes necessarily internal? If a framework has to manage them, if a framework instantiates them and connects them with other dependencies, if Hibernate comes into your persistent classes and tries to read the fields, how internal are those fields really? Or if you use Jackson for data binding, for JSON representations, rendering out objects into JSON documents. Actually, if you try to look at existing code in particular, you're going to find out that a lot of it isn't really internal. So you're going to end up with Jigsaw definitions where a lot is actually exported. It has to be in a typical enterprise project. So that's of course that's not a complaint about Jigsaw. This is a general implication of a conceptual implication of using a module system. It was the same thing in OSGI. It was actually even worse in OSGI with all the class loader business and the dynamic reloading there. But it's the same kind of experience. There's suffering involved. You're going to suffer a little at least. But it is doable. And if you want to do it, put the framework jars, put Hibernate, Jackson, the Spring jars of your choice onto the module path, design your application modules with such module info descriptors, compile them along with your application, refer to other modules that you intend to see where you're trying to use API from, refer to them by their module name, which by default is in the automatic module mode in JDK9, it's basically the name of the jar file without version information with dashes replaced with dots. So if you take spring-jdbc-5.0.0 jar, the module name is this spring.jdbc by default. In JDK9 they call this automatic modules. Since we are not shipping module info descriptors ourselves yet, so when using Spring, Hibernate, Checks, and any other common library on the module path, on the JDK9 module path at the moment, you're essentially having an automatic module where everything's exported with a default naming convention for the name, but it's entirely usable for application module purposes. And that's the only thing that really matters, right? It doesn't matter whether a framework jar has a module info descriptor inside. The only thing that matters is that you can do things the Jigsaw way in your module descriptors that you ship in your application modules. It's the only thing that really matters. And automatic modules are a fine way of getting there with existing frameworks and libraries, because none of those is going to ship module info descriptors right now. Not us, not Hibernate, not Jackson either. Right, there's a lot more to say about Jigsaw, but let's leave it at this. So summarizing, JDK9 is a smooth upgrade. Stay in class path mode if you want a smooth ride. If you're up for a little challenge, then opt into Jigsaw and just play with it a little. It's an interesting experience. You're going to learn quite a bit about Jigsaw by just trying. I personally use a Spring Hibernate embedded HSQLDB application that I compile and run from the command line to really track the JDK9 Jigsaw upgrades. It's an interesting experience, right? Because there's no IDE support for it yet anyway. But even there, it's entirely doable, and there are ways out of almost any problem through a command line flag. So this is still a pre-release on the Jigsaw end, right? So Jigsaw is not actually set in stone yet. Some things may still change. This naming policy may change, theoretically at least. But if they want to release in July, I'm pretty sure it's not going to change anymore. Right, but that's our position, right? We're going to keep it up like this. We may have stronger Jigsaw support by actually shipping module info descriptors in a future Spring Framework generation, a Spring Framework feature release even. That's up in the air. We haven't decided that yet. We are entirely driven by additional value that we can create for the application development experience, right? So we're not going to do it for our own purposes. We're only going to do it if there's an application development story enabled by it. And at the moment, we're quite happy with the story that we get right now. All right, so much for JDK9. It was actually a little bit more than I intended to say, but it's of course an important enabler for many things to come. I always see the JDK as an inspiration in its own right. And the moment that you upgrade to JDK9, you're going to find quite a lot of nice little features, the collection factory methods, map.off, set.off. And there are nice things even at the API level. Even if you choose to upgrade to the Java 9 source level, there are nice little API refinements in completable future, in Java util optional, in the collections. So by all means, embrace it, right? But you can consume all of those things without Jigsaw, even the API enhancements. Even source 9, source 1.9 does not mean Jigsaw. All right, so much for that. A related topic is actually HTTP 2, because in JDK 9, among the runtime enhancements in the JVM, they are also going to ship an updated protocol stack, an ALPN.
So can I have one question?
Sure, yeah. Yeah, I meant to ask, JDK 9 questions, right?
I'm waiting for that moment.
Sure. Sorry.
So does it mean that I will have to declare my dependencies in Maven and then in that module Jigsaw system, like that requires ping JDBC?
Yeah, because Jigsaw doesn't do anything about provisioning. That's a design decision that they made. That they don't manage versions and they don't do provisioning. So Jigsaw doesn't know about repositories where artifacts are coming from. It only knows the runtime representation of those artifacts. So it's a kind of different concern. Whereas a build system like Maven is basically a repository solution, right? With managing versioned artifacts. That's a quite different thing. The Maven team is very aware of what's happening in Jigsaw. They're trying to have where you can infer module descriptors from the POM information, at least generate like a basic descriptor, but it's a separate artifact. A module info is like package info, it's a Java file. This is a Java language file that's compiled by the compiler, a class file at runtime. It's code, it's your code, right? And even if an IDE or a build system generates a basic arrangement for you, you're going to have to manage it. If you update the dependencies in the POM, you're going to have to update the dependency descriptor, not for a version change, but for a structural change. You're going to have to touch the module descriptors. That's, to some degree, a little unpleasant, right? We're talking about class files after all, yeah? So you have to do it at build time. You can't do it at bootstrap time or even by opening up jar files and changing their manifest, right? It's not manifest information, it's actually compiled code. But yeah, like in OSGI land, where everybody kind of specified their dependency version ranges separately, and there are several sources involved. It's not as bad as with OSGI, but there is a duplication of structural module dependency information, indeed. That's unavoidable. The only way out is you could choose to deploy your application modules as automatic modules as well. So basically, don't ship module info descriptors. Let the JVM infer default characteristics from your jar files. Default module name, and automatic modules see all other modules on the module path. So you still get runtime benefits out of it. You can still reflect upon the structured runtime, but you don't have explicit requires clauses. So basically all the modules on your module path see all the other modules on that module path, but they're still modules, with boundaries. And I find that quite nice, because then you don't actually have that duplication. The duplication only shows when you start coding a module descriptor. But yeah, in all fairness, if we turn the question into where's the benefit, right? Then duplication is not necessarily evil, but you have to have some. You need to get some value out of it, right? You're not going to suffer through visibility boundaries and duplication of structural information for no benefit, right? And that's where the problem is, in essence. I just don't see that strong benefit in Jigsaw for typical application development at the moment.
Can I somehow describe which Java runtime environments jar do I need in this module info? Like rt.jar if I need it, or some just limit the parts of JVM?
There's referring to the JVM to the core Java libraries. Yeah. There's an implicit dependency on java.base in any module. So that's like in a Java source file. The import java.lang, right, which is implicit in all Java source files. So there's an implicit requires java.base here. And Java.base is not the entire JDK. Java.base is literally the core libraries. There's no JNDI in there. There's no RMI in there. So it's the traditional JDK 1.3 era core libraries, right? But the other modules are being shipped and they have a name, right? So even if you want to use JDBC, for example, requires java.sql. So it's part of the JDK 9 distribution, but not part of java.base. So there's a whole namespace, probably like 20, 25 modules that come with JDK 9, java.something modules that you can choose to require here. And that's a benefit in its own right? The JDK itself being decomposed into modules. So I'm not saying that the module system generally is not worth having. The question is, do we really need to work that way at the application level? There are runtime benefits that we get through the JDK's own use of modules internally. Personally, I'm just not convinced that the world at large is going to see the benefits for application usage here. It just is a smoother ride in class path mode, and that's just my prediction. Now we always try to have a kind of expectation that we work towards, and my expectation here is that most Spring-based applications are going to upgrade to JDK 9 or try the upgrade rather early. We generally have an audience that does that rather early. But if 10% of those even try Jigsaw, that's already a high number.
So you are saying that there is no benefit, but not even the memory footprint? Or?
The memory footprint at the JDK level you will get in any case, right? Because even in class path mode, the JDK itself still is on the module path. Technically, if you're doing class path mode in JDK 9, you run into what the JDK calls an unnamed module. So you're still in the module path, right? But you have everything you're deploying in a single unnamed module running next to the JDK modules. So you still get runtime benefits. But you don't have an inner structure within your deployment unit. Everything that you're deploying, the libraries, the frameworks, and your own code, lives within one large unnamed module. One deployment unit, basically. In a microservices arrangement, that's pretty much what you want, right? You don't necessarily need more inner structure in your own deployment unit. You don't need the JVM to know about the inner structure beyond that. It's a tough call, but opting into Jigsaw is a design decision. It's not driven by runtime concerns. So if you choose to use Jigsaw for your application modules, there's basically only trouble, but no runtime benefits really. You're doing this for a design reason because you choose to work along those lines. You choose to decompose your project into modules and to enjoy some benefits from that formal decomposition that you're doing. Maybe because there's splitting the development team or enforcing a separation of concerns harder than before. It's motivated by design considerations in the development process, not by runtime benefits, from my perspective at least. Within the JDK, that's of course different. The reason why they started it was runtime benefits within the JDK, right? Why do you want to bootstrap all the parts of the JDK if you're not even using them? Let's only bootstrap java.base and bring the rest in as needed. In all fairness, that's not so different from how class loaders worked before. If you're not touching a class, it's never been loaded. So even that's a little, that argument is not as strong as it initially sounds, but there's at least some meat in this.
Does Jigsaw handle versions anyway of modules?
Not internally. So at runtime, you only have a set of modules, basically artifacts that are being combined. There's only ever one version of each artifact. If you're trying to deploy 2 versions of the Spring JDBC module, you're going to get an exception on startup. It's actually a benefit in Jigsaw is detecting class path conflicts. You can see that when it's a startup, it's a development time benefit in the end, right? But if you have several versions of the same class or the same module on your class path, the class path is not going to complain. It's going to load the first version on the class path. Whereas in the module system, there's an immediate detection of that conflict, like package X shows up in 2 modules, cannot happen, right? JVM refuses to bootstrap. So in that sense, there is some enforcement of the uniqueness of artifacts on the class path. But there are no versions. You choose the versions by bringing them onto the module path, or your build system chooses to bring certain versions onto the module path. But at runtime, there's literally no way to work with the version, right? It's not like an OSGI where there could be several versions of the same artifact at all. At the moment, there is at least retention of the version information. So in the module descriptor, you could have some metadata indicating a version, but that's basically just for debugging purposes, right? Which version am I running against here? Not for managing several versions at the same time. So it's my own design, opinion on Jigsaw. It's a very sound compromise that they chose. Literally just structural information at runtime without this provisioning, without repositories, without separate versions of artifacts, without parallel running of completely isolated versions of modules. They don't do any of this. It's literally just the class path in a more structured form. But even that is a bit of a challenge to use, right? But it's what they attempted to do is perfectly sensible. It just shows that there is a lot of inherent complexity in even the basics of such a module system at runtime. Yeah, it is what it is. So if I'm saying that I only expect 10% of Spring applications to even try, we infer priorities from this, right? We always operate under a certain opinion. At the moment, we don't invest into extensive research of what we could be doing with Jigsaw. We're just trying to enable it properly if somebody chooses to use it. That's all, right? We're trying to play nicely, but it's not a particularly strong focus in terms of our R&D efforts, if you will. We put them somewhere else where we see more mainstream potential at this point. And we're very JDK8 baselined anyway. I mean, obviously, JDK9 is not going to be found in production environments right the next day in July, right? It's going to take a while for it to show up. So just some natural priorities that we derive from this. All right. I'm going to refer back to JDK9 actually twice more. It's kind of cross-cutting a little. So, if there are any other questions, of course, on JDK9, feel free to drop them in as they materialize, right? So we can refer back to things we've been discussing before, also at the very end. No worries. But this one is actually related. JDK9 ships an ALP NV3 stack, which is basically the SSL stack in an incarnation that is ready to serve HTTP2. It's the first JDK generation to do so. So inferring this back to JDK8, of course, we have a bit of an issue with existing JDK8 installations here. I mean, HTTP2 is such an obvious step forward, from what we've been using before, that it's really a bit of a shame that we are not quite ready to embrace it wholesale in the Java industry yet. I mean, a lot of stakeholders did their job, right? The browsers, the mobile browsers, a lot of the networking infrastructure out there is already at least ready for HTTP2. And the initiator is always a client, right? A client talks to a server system and it suggests to use HTTP 2.0 instead of 1.1. If the server refuses to do so, it falls back to HTTP 1.1 communication. So obviously, everything works in any case. But it's a bit of a shame that in particular for Java-based servers, that is the norm at the moment. We are forcing all the clients to downgrade to HTTP 1.1, even if the clients would be perfectly ready and willing to use HTTP 2. HTTP 2 with all of its benefits, the binary representation at runtime, the connection multiplexing. And my favorite is actually headers compression, this sort of total nonsense that we do in HTTP 1.1, where we repeat the same headers for every single HTTP request that we're sending from the same client to the same server. This stuff is so obvious, you know. Put a symbolic reference onto this combination of headers, and the next request says same headers as in the previous request, right? Saves quite a bit of bandwidth, in particular in this modern world with all the little short HTTP requests that we are sending all over the world. So HTTP 2 is, from that perspective, really important for modern day web architectures. HTTP 1.1 was perfectly good enough for a long while, right? 20 years, basically. But we really need HTTP 2 right now for what we're doing, for all the kinds of architectures that we have already, and for the ones we're going to build over the next few years. We really need this. By the way, in case you have been familiarizing yourself with HTTP 2, the whole push resources stuff in my book is actually the least important feature in HTTP 2. So it's a little bit like, well, maybe Jigsaw. It's not the same kind of comparison. It doesn't really work, I guess. But everything else is so worth having and so transparently available to our applications that basically forget about the whole resource push thing. That's not the reason you're going to use HTTP 2. Why am I saying this? In Servlet 4.0, which is the first specification coming up in the Servlet world, right? The first Servlet version that actually enforces HTTP 2 support. Finally, it's not actually there yet, so also scheduled for July, along with the Java EE8 umbrella. It's great that we get a Servlet specification finally saying that all Servlet containers implementing Servlet 4.0 have to provide HTTP 2 support out of the box. That's great. But if we look a little bit more closely, the Servlet specification itself doesn't actually do that much about HTTP 2, because that's largely a wire protocol business, right? At the Servlet level, Servlet is an abstraction after all, right? It abstracts requests and responses in a way where we can totally ignore HTTP 2 1.1 versus HTTP 2 for pretty much all purposes, right? A servlet-based application does not have to take HTTP 2 into account. It's largely an infrastructure problem. Setting up the servlet container, setting up the protocol stack at the JDK level in a way where the runtime server is able to accept HTTP 2. Applications, all the applications that we have are kind of naturally capable to work with HTTP 2 to accept HTTP 2 requests and send HTTP 2 responses without much change. Admittedly, there may be some things you can finally do that you were not able to do before. You may be able to do some optimizations if you know that you're running on HTTP 2. There's always the bonus, right? But you get a lot of the benefit by just upgrading the servlet infrastructure and running the same application on an HTTP 2 ready servlet container. Now, in Servlet 4.0, that doesn't really show, because the transparent benefits, well, there's some text in the PDF file, right? In the Servlet specification PDF that talks about this, but Servlet 4.0 API-wise basically doesn't really have HTTP 2 specific changes, except for the new push builder. So what happens? Everybody, both the Servlet expert group and a lot of the coverage out there, if somebody talks about Servlet 4, writes an article about Servlet 4, conference presentations about Servlet 4, they always talk about the push builder. The only new API, basically in Servlet 4. Not entirely true, there are a few new setters on Servlet context, but it's the only really interesting new API in Servlet 4. And the shame here is that I don't really see a need to programmatically trigger pushes. I have no idea, even after 2+ years, I have no idea what to actually, who to recommend this to, right? If you're building a framework with certain correlation assumptions or correlation knowledge about certain resources, you could try to proactively push them programmatically, but in a regular application, by all means, just forget about it. There's even a discussion out there in the HTTP 2, in the wider ecosystem around HTTP 2, whether it's even a good idea to do this. to do this ever. But the only mechanisms I saw that I liked are in the servers themselves, where the servers infer certain correlations from typical request patterns, right? So a server can learn that if a certain request comes, usually there's these other requests following for it comes some JS or CSS resources. It knows that the same client is going to send certain kinds of requests for certain resources in immediate succession. So by learning that statistical pattern, it can proactively push those resources on the first request already. It's something you can leave up to the server. It's basically server configuration. I don't see this creeping into our application code. So from an application perspective, Servlet 4 is basically a transparent, almost boring upgrade. The only really interesting part is the HTTP2 support in the products, in the server containers, in the servers themselves. And ironically, for that part, it's not so important that a server actually is Servlet 4.0 compliant. We have Servlet 3.1 containers right now, like Tomcat 8.5, JD 9.4, and Undertow 1.4 underneath Wildfly, but also independently. All of those are HTTP2 ready. They are Servlet 3.1 containers. They don't have a push builder API, but the transparent benefits of HTTP2, they already deliver for Servlet 3.1 based applications. That's what we strongly recommend at this point. If you're interested in embracing HTTP2 at all, in enabling HTTP2 at all, check out the latest versions of those containers. The tricky part is the JDK setup, the protocol stack in the JDK, but they all have ways of getting around it. As long as you can modify your JDK installation, it's all doable right now. So by all means do this. Don't wait for Servlet 4.0, the PDF file, and don't wait for Servlet 4.0 products either, even if Tomcat 9 is pretty advanced in the meantime, pretty far along. Don't wait for those. We have a tendency in the Java ecosystem to always wait on things, on somebody else to formally declare something, right? It's a bit of an excuse to say, like, I can't do HTTP2 because I have to wait for Servlet 4. It's just not true. If you're saying I'm waiting for a JDK 8 upgrade to finally give me an ALPN v3 stack out of the box, that's a better argument in case you need an excuse. But that's actually planned to come. Unfortunately, there's no hard statement on that yet, but common sources, or actually the people deciding this, do say that they want to ship a JDK 8 update along with JDK 9, so also in July, where they backport that SSL stack, right, that ALPN stack, to JDK 8 update. I don't know what that's going to be, 130, whatever. That's actually the one single thing I'm really looking forward to, not Servlet 4 containers. The moment that we get an ALPN v3 stack in JDK 8, in a JDK 8 update, it's much easier to configure existing servers to use HTTP2. That's really a step forward. That's what we need, right? Or of course, go to JDK 9 right away. You're going to get the stack there out of the box for sure. So that's what we're focusing on at the moment. We are already for quite a while. We're trying to do everything we can to enable the use of HTTP2 in Spring-based applications. On the server side, by supporting those latest servers in Spring Boot and also at the framework level, which is not always so trivial. We do embrace Servlet 4. We have early Servlet 4.0 API support already in Spring Framework 5.0 M5. Even my special darling push builder, in a Spring MVC handler method on Spring Framework 5.0 M5, you can declare a push builder argument in your Spring MVC handler method signature, and we're going to give it to you. Even if, from the servlet request, right? If you're running on a Servlet 4 container, like on Tomcat 9, Milestone 17, or whatever it is, we're going to give it to you, but I unfortunately don't really have a recommendation for when to use it. But if you know that you want to use it, it's there, and first class injected into an MVC handler method. So we are testing against Tomcat 9 and Servlet 4.0 in general already. We have the the mocks, like our servlet mocks, updated to servlet 4 level, including the new setters for session timeouts and encodings on the server context. So we're doing everything we can to have early servlet 4.0 support. But being pragmatic, what's most important is actually this making it work in practice, in production, and not the waiting for servlet 4.0 part. There's so much more to say about this, right? Almost worth a dedicated talk. Like in a microservices architecture, you're going to implement quite a bit of programmatic HTTP, basically programmatic HTTP client usage, right? You're going to initiate HTTP requests from one service to the other. Of course, it's equally important, if you want to embrace HTTP 2, that those programmatic clients are actually HTTP 2 capable, which is non-trivial. There is no HTTP 2 support in the JDK itself, not even in JDK 9, not in the regular Java SE9. There's only an optional experimental HTTP 2 client that nobody's going to use because it's marked as experimental, even if they ship it out of the box and it's a separate module. You know, I don't see the point of why they're even shipping it. The only way of doing HTTP 2 for a programmatic client is to use an external library, like OK HTTP 3 at least is HTTP 2 capable. So revisiting the client libraries, if you're using Spring's REST template, setting up REST template with the OK HTTP 3 client request factory may be a really good idea for a really complete HTTP 2 story. All right, let's leave it at that. Any immediate questions on the HTTP 2 topic beyond what I was trying to anticipate already? So that's all infrastructural stuff that we talked about up until this point. Let's move on to a little bit more source codey stuff now. So it's quite a change now. What's up with the functional story? Functional means many things to many people, right? We actually have a very specific understanding of what we're trying to accomplish here. I've already mentioned that we had a strong focus on the annotation-based model in Spring Framework 4.3. And this translates very nicely onto 5.0. If you have a 4.3-based application and you want to run it on 5.0, you just take the code that you have and you have a first-class, non-deprecated Spring Framework 5.0 application. Of course, right? We're not going to change anything about this. And this is the mainstream. Even in Spring Framework 5.0, most of the code written is going to be written within the annotation-based model. Definitely. Right? There's no doubt about that. At the same time, we always like to explore different ways of consuming our framework functionality. This was always the case, right? The annotation-based model initially was this sort of advanced stuff, right? The traditional model in Spring was XML-based. There still is an XML-based model, even in Spring Framework 5.0. And the annotations were kind of what we did because we thought somebody might be using it at some point, and it became more comprehensive in every generation, pretty comprehensive in 3.0 then. But yeah, it started actually quite early in 1.2 with transactional annotation initially. So the annotation-based story is of course ongoing, right? And I don't see an end here either. We have some refinements that we bring into 5.0 in the annotation-based model. There is always things to do, but essentially it is pretty feature complete, and pretty much what we meant to achieve there. In other frameworks, other libraries, other language ecosystems out there, it's a little unusual to do things with such intense use of annotations. So if you're talking to people outside of the Java space, the number one, comment or complaint that they're going to have about Java is like that they find this whole annotation business a little bit weird, right? But in Java land, we don't really have some isolated use of annotation somewhere. We have a lot of libraries, a lot of frameworks, a lot of APIs being quite nicely aligned in their use of annotations. That's a good thing, not something to worry about at all. But for certain styles of applications, certain styles of architectures, for in particular microservices architectures with reactive HTTP containers, there is an obvious way of consuming them in a more functional style. So the kind of natural way to express interaction in certain architectures is essentially callback based. That's the reason why quite a few other frameworks out there have a more functional way of using them. So what we're exploring in Spring Framework 5 is to bring some functional style into the Spring world, or as a kind of alternative, as a kind of offering, right? If you want to build a little Spring-based microservice with just a couple of components, a couple of endpoints, to just configure those in a quite different way, entirely supplier-based with functional bean registration, functional endpoint registration, no use of annotations whatsoever. Then we were thinking like, well, not just no use of annotations. Let's aim for complete Spring applications not using any reflection anywhere. That's actually the more radical goal. So that's a bit of an extreme, right? Just like there's the XML bean definition model, there's the Groovy bean definition DSL, there's the annotation-based, the entire annotation-based story. There's another extreme, right, at the boundary of what we're doing. This is basically entirely programmatic, functional style usage of the framework from the core container up to the endpoints like HTTP endpoints, web endpoints, without any use of reflection. Is actually a sort of extreme. I don't recommend artificial avoiding of reflection at all, right? Reflection is not a bad thing. We tend to overuse reflection maybe in the Java world a little. This is more of a challenge for ourselves. Now, we are trying to revisit our core container, our core functionality, from a perspective where it should be consumable without any use of reflection. That's a quite interesting challenge, and there is benefits coming from this already. Well, and the other inspiration, of course, is functionally oriented languages. Essentially, we have two central inspirations here. It's the Java 8 functional style. Basically, when we say functional, we mean functional the same way that Java 8 means functional, like Java util collection streams, the whole Java util optional business, like a more monadic style of interaction. So we mean lambdas and method references, right? All of the things that Java 8 brings onto the table, this is basically what we mean. We also mean functional as in Kotlin these days. So back to Kotlin. Kotlin has some really interesting use of functional design elements. It still is largely an object-oriented flavor of a JVM language, but it has a stronger focus on functional language elements than even Java 8 has. So within those constraints and with those inspirations in mind, we are kind of revisiting core framework functionality on our end. And for a start, let's look at bean registration. We're going to look at endpoint registration next in the reactive chapter. So this is really the bare fundamentals of what we're doing, right? There's quite a bit more. But let's assume you're trying to configure a Spring application context, in this case with just two beans, and you want to do this in a functionally oriented style, and ideally even avoiding reflection, and definitely no use of annotations at this level. So this is the simplest you can do in Spring Framework 5.0M5 at the moment. This is actually not that new. Generic application context is a really old class. Generic application context always had register bean definition methods, but at that point, you're really into the inner workings of bean definitions. Too much metadata that you see directly, and we are trying to provide a bit of a simpler facade for it, basically. A couple of methods, all called register bean. The simplest version that just takes a class is sort of equivalent to registering an annotated class on an annotation config application context. Just inferring all the characteristics from the class, right? Using its default constructor in the simplest version, and kind of just looking at its callback signatures, callback interfaces implemented, that sort of thing. Inferring a bean name from it. So that's the simple part. Where it becomes interesting is the supplier callbacks. We call them instant suppliers. So by registering bar.class, with a lambda expression in this case, building an instance of bar, a new instance of bar. This is literally a Java 8 supplier and a Java 8 lambda expression used here. Every time, for example, for a prototype bean or for a scoped bean, every time the container needs a new instance of this bean, it's going to dispatch straight to this supplier. So you're literally in control, right? It's almost a little bit like a factory method, but as a lambda expression. So the supplier callbacks, of course, in this particular case, calls back to the application context itself to find collaborating beans. So it says like, I'm creating a new bar instance, and I need to, this is a bar foo constructor, I need to grab a foo instance and pass it into my bar constructor. So I'm calling back to the application context, give me a default foo instance. It could do anything, right? It could use any retrieval API on application context. And building a programmatic combination of dependencies that way. This is actually not so different, from what annotation-based dependencies express, but it's not left up to the container in terms of looking at annotations and inferring rules of processing from them. The rules are very explicit. They are programmatic calls. In the variant below here, there are just some minor twists, two twists, right? First of all, what we see here is that there are actually ways to go a little bit deeper, fine-tuning bean definition characteristics. There is a whole array of what we call bean definition customizers. They are meant to be specified inline. This is basically a separate lambda expression, right? It's basically the component type, the instance supplier, and the next line is the first bean definition customizer as a lambda expression. So if you have several flags to set, you can just say bd set lazy init, bd add qualify, bd do something in separate callback lines. The register bean foo variant also has a little twist. Like, what's happening here? Well, it's an instance supplier, but it's not using a Java 8 lambda, it's using a Java 8 method reference in a method reference to the constructor, to the default constructor. So this basically says, every time you need a new foo instance, call the default constructor. So, okay, what's the big deal, right? That's the same rule as here. But here it is a method reference, and the Java 8 compiler actually does not use reflection to dispatch to lambdas or method references. It compiles a synthetic method with an invoke dynamic dispatch straight to that callback. So there is no reflection involved, not even for calling the default constructor. So we're taking this pretty far. Even doing class new instance is basically a reflection, right? So by specifying the callbacks even to default constructors explicitly, the entire arrangement is completely free from any reflection. So that's what we do at the core container level. This style of registration shows up in quite a few corners of the framework in the meantime, in particular for endpoints. At this level here, I mean, take it for what it is, right? If you're building a large application with a very decentralized arrangement of hundreds of components, I mean, yes, you could do it this way, but obviously it doesn't really scale to arbitrary levels. This is meant to be used for more focused, smaller application context with a certain innumerable number of components, manageable number of components that maybe fits on a single screen or whatever guideline you're using, right? It's in particularly meant for smaller, like microservice deployment units, possibly also for testing arrangements where you do half integration tests with Spring application contexts, but very isolated combinations of components only. So it's meant for particular fields of usage, not for large enterprise scale application contexts where you're probably better off with the annotation-based model and component scanning, right? You can mix and match. So instead of generic application context, you could instantiate an annotation config application context or activate annotation processing on the generic one that works externally as well. But by combining the annotation-based facilities with programmatic registration, you get quite nice mix, right? We actually have all the auto-white facilities, all the annotation-based processing active then. So that means that for register being foo, we're going to look at the auto-white constructors. We're going to see post-construct and pre-destroy methods, everything we're doing in the annotation-based model, but we can still register instance suppliers in combination with annotation-based processing of the lifecycle methods and everything else. It's a quite interesting combination, where this is sort of an alternative to configuration classes and the admin factory methods. I mean, it's essentially modeling the same thing. In combination with annotations, you very literally have an alternative to admin methods at this level. So this is the Java 8 variant. The Kotlin variant is actually even more concise because we're making, in the Kotlin language, we're making use of some Kotlin-specific reflection features. Kotlin is not just a language variant. It actually comes with a class library, with in particular with a reflection library that frameworks and other libraries can use to interact with Kotlin-based code in a more sophisticated fashion. So this is the same code. It sets up the same stuff. Let's take the example above first, right? This looks almost like this one. It's actually not that different. Although here, what we have in here is a Kotlin function. I mean, it's sort of like a Lambda expression, but not quite, right? It's actually a Kotlin function. And Kotlin functions have a deterministic return type that runtime reflection can reason about. So for a Java 8 Lambda, we have no idea what it produces, that's the main reason why you have to specify the component type explicitly. Because the Lambda doesn't give us any clear indication. Whereas in a Kotlin function, we have a very clear indication. We know exactly what the Kotlin function returns. So we know that it's creating a bar instance. We don't have to repeat the argument. The syntax itself is, that's idiomatic Kotlin. It's not that different. We actually call that the Kotlin's Java style. It sort of looks a little Java-y still. It's not that far from Java. Kotlin actually has more to offer, right? It has different usage styles. This little thing here has been popularized through Gradle's use of Kotlin. So if in recent versions of Gradle, as an alternative to the Groovy-based DSL, there is a Kotlin-based DSL, and that's using a similar nesting model. This is basically the same thing, just by using different Kotlin language features. But underneath the covers, it's exactly the same API calls. So with the inline type declarations, this requires a little getting used to, right? But the Java style is actually very straightforward. And we have, in the meantime, we have quite some early adopters of Spring's Kotlin support. There are even complete sample applications that are running out there on Spring Framework 5.OM5, entirely written in Kotlin. For example, the conference website for the Mixit conference in Lyon, which is happening in a few weeks, is is entirely written in Kotlin, including the CFP app and the schedule app. And that's a Spring 5.0 M5 application written entirely in Kotlin. So how do we actually do this? This is a little bit more than just using the Kotlin compiler with Spring Framework 5. We actually ship Kotlin extensions. So if you download Spring Framework 5.0 and 5 jars, they come with some Kotlin extensions. The Java compiler is going to ignore them completely. It's basically a convention-based arrangement where the Java compiler doesn't even see it. But the Kotlin compiler realizes that for generic application context, for the Bean Factory interface, for many interface types actually in Spring, that there is an extension. And the Kotlin compiler, by convention, just picks up that extension out from our jar file and immediately uses it. And this extension model is a little bit like in Groovy. It allows us to add additional signatures, like overloaded methods, to existing types, only for the Kotlin compiler. This is exactly what we want to do here, right? Because this is an overloaded register bean method, taking a Kotlin function. Even this is an overloaded register bean method, taking a K-class argument, a Kotlin reflection class, making the syntax even nicer in Kotlin. We introduce those overloaded methods through Kotlin extensions that we ship out of the box. It's a very nice model, actually. I was surprised that it's that useful. The decision to ship those extensions came rather late. We only started doing this in December, when it was clear that we would get a Kotlin 1.1 final release in time for Spring Framework 5.0. And Kotlin 1.1 recently went final. We have a very close relationship with the Kotlin team in the meantime, so we spent quite a bit of time with them trying to iron out some, inconsistencies that are always there. They're really very open to this. In the meantime, there's a couple of really nice conventions in the Kotlin Spring plugin. It's really they do everything they can for Kotlin to become a good citizen in a Spring-based application. So they really motivated us to ship our Kotlin extensions out of the box. It's a really nice collaboration. Totally optional, of course, right? Obviously, this is the main language arrangement that we're working towards. But the same kind of facilities work really nicely in a more functionally oriented language like Kotlin. All right, the whole functional part is going to reappear. It's very tightly connected to the router function model in our reactive story. But so if there's any questions around functional, we can take them right now, or we're going to see some more functional stuff in just a bit, but if there are any immediate ones.
We were talking about like zero reflection. Were you
Yeah.
guys looking into more of a like compile time dependency injection or this sort of stuff? Like
in Dagger?
Scala projects and Lightbend?
Not
you guys
in the
just explored it.
Yeah. We observe what's happening, right? I mean, Dagger, that's kind of nice. What we're doing here, in the functional registration model is not exactly compile time dependencies in the same ways, but I would argue it delivers very similar benefits, right? It's extremely efficient setup. In that arrangement, you wouldn't do any component scanning. There's literally no annotation processor active. So it does exactly what it says, right? Everything's in the code. It's using straight method dispatches everywhere. So to some degree, it's kind of our answer to the what about more efficient bootstrap setups. We actually have more than this. And now in Spring Framework 5, we also ship an index model for component scanning. We're generally trying to optimize startup times. But the outcome here is actually really, really nice, right? It's very, very straightforward and also very memory friendly. So in that sense, I don't really see us going more into Dagger territory. I really appreciate Dagger for what it does. And in an Android environment, things are a little different, of course. But for a Java server deployment arrangement, I would argue that what we're doing here is a perfectly fine balance in practice. But we don't intend to go beyond this, right? We make certain picks where we think it's worth investing into, and we're really happy with the arrangement here. I hope that's enough of an opinionated answer.
I will kind of refer to the question. What's your thoughts regarding Scala?
Yeah. It's well. How much time do you have? That could be a rather lengthy answer. I'm trying to keep it brief. We had a Spring Scala project. We actually still have it, but we don't actively maintain it. So we used to invest into a Spring Scala research project where we were trying to come up with, there was a Scala functional application context, and there were a couple of things that are sort of, that have a similar smell as what we're doing here with Kotlin. We were just never totally happy with the outcome. So both stylistically and in terms of the attractiveness towards a Java audience, we were never really happy on our end. Happiness on our end is not the only goal, right? So the other part is we never really managed to attract a Scala-oriented audience either. In Scala land, there are Scala ways of doing things. There are really nice Scala-oriented frameworks. I mean, Akka and Play are really nice at what they're doing. And we've been told that basically, nah, I'm not really going to use this, right? So it was, on our end, an initiative without an audience, without much of an audience. And with anything we're doing, we're always looking for an audience. I mean, it sounds a little simple, but I mean, if you think about it, there are actually quite a few R&D projects out there that are not audience-oriented at all. So whatever we do always needs to be kind of ready for even larger scale audiences. And in Scala land, I mean, Scala is fine in its corner of the world. I just don't see it getting closer. So even with recent efforts on Lightbands and Legum, as a microservices framework, they seem to work more of our stack kind of vision, right? Not integrating with anybody else's stack much at all. And we are a very integrative solution. We're always trying to embrace wider Java ecosystem trends, and Groovy and Kotlin are just much closer to that mindset. Much easier to integrate with existing libraries. I mean, even if you talk about basic integration with collection types and all that stuff, Groovy and Kotlin are just so natural. And in Scala, you always have a bit of a parallel world in terms of what the APIs are actually using and consuming there. So that's why, right? So we did actually we spent significant time on this. We even had several milestone releases of the thing. But in the end, a couple of years ago, we decided not to continue our investment into it. As a community effort, anything may happen. But if there's not much of an audience, there's not much of a community, so not much is actually happening, in all fairness. And for other languages, the same reasoning would apply. Is the language attractive enough to people with a Java language background? Is it straightforward enough to integrate with Java-based APIs, frameworks, and libraries? That's the main characteristics that we look for. And Groovy and Kotlin really shine, both really shine on that front. I have yet to see any other JVM language that comes close here. So even Ceylon, Clojure is of course quite different anyway, but even Ceylon is sort of not really trying to be friendly to Java libraries, but then not really. We need languages, JVM languages, where they're really committed to a strong Java integration story. Commitment in the language design and commitment in the people. We need teams to work with. Open source is about collaboration with other open source teams. And we sound simple again, but we want to work with people who want to work with us. If you know what I'm saying. We want to work with people who really want to support us in our initiative, where there's a common goal that we're working towards and not kind of just a tolerance of somebody else's effort. Anyway.
So you see that the Kotlin is used all over the world?
Kotlin, at least given the short 1.0 final plus life that it has managed to attract a significant audience in a very short time. So if you extrapolate that trend, it really has some potential. There are no guarantees, of course, right? But Kotlin, they really mean it. I mean, my main concern about Kotlin was, is this really a serious effort on JetBrains' side? Do they just do it because they can, or do they do it because they want to make a difference? And initially, I wasn't convinced, but as of like last year, they really started heavily investing into it in every single respect. They are now doing a Kotlin conf in San Francisco in November. Right? They're even setting up a conference ecosystem around it. They really mean it. They basically committed to exploring the potential of that language. Right? In the end, it may still remain a niche. We never know. But it at least has the potential to become a sort of Groovy companion, right? Groovy is basically what we see as the ideal reference, right? We don't see a JVM language as competing with the Java language, right? We don't see it as, it's the next kind of Java, like Java is old school and this is the new thing. Not like that at all. It's sort of Java's the mainstream language. Where's the 10% potential, right? And Groovy definitely has that already for a number of years, and Kotlin at least has a potential to get there. I admit that from our perspective, there's always a little bit of personal opinion involved, right? So do we have a few people who really love the language? That's an important characteristic. We actually have a couple of people who are really into Kotlin. We need that, right? There needs to be somebody who really lives and breathes that thing. Otherwise, we're not going to do as good a job as we possibly could.
Does anybody use Kotlin in this project?
That's a good question. Is anybody interested in using Kotlin? That's what we're actually looking for towards it. I mean, if you'd like to play with it, now's a great time. Take Spring Framework 5.0 in 5 and see what you can do with it. It's as good as it gets from the Kotlin support. There's very little that we do for RC1 still. All right. So the reactive topic. This is easily worth an entire evening, right, on its own. So I'm going to do a bit of a motivation in combination with an introduction to our source code style here. But the topic is very deep. So let's start with why are we even bothering, right? Why do we care? In Springland, if it's about web applications, we were traditionally very servlet focused from our inception, right? We started back in 2003, where servlet containers were only really starting to become as popular as they are now, the early days of Tomcat. This is, of course, still very much the case. The typical Spring-based web application on the server side is servlet container-based. We had portlet support for quite a while. If anybody cares, it's gone in 5. It's still in 4.3, so if you want to keep using it, stay on 4.3x, right? But we always had, actually portlet support was introduced very early. So we always had this parallel servlet portlet stack, but obviously the servlet stack was what everybody was using, and there was a bit of a very specific part of the market only but an interesting and sort of important part of the market that we did the portlet support for. But the days of portlets are gone from my perspective. And I would argue, although that's a little more debatable, that the days of JSF, Tapestry and Wicked are probably gone as well, at least from a strategic perspective. But that's a little more debatable. Portlet is definitely gone.
Do you think the server-side rendering is gone also, like that?
Server-side rendering, at least to the degree as it is being modeled in like Wicked or JSF, that's probably not. I mean, looking at where Angular and React are going, I have a hard time arguing that this is going to continue. There's a lot of existing stuff out there, of course, and those apps may still run in 10 years, be maintained in 10 years. That's okay, right? We still ship our basic GSF integration. I'm not saying we're abandoning this. We are abandoning portlets primarily because that thing isn't really evolving. And it's such a niche in the market where I don't see a commitment from any vendor except for Liferay anymore. And I don't know, right? It reached the end of its investment life on our end. And we are introducing a new web stack, the Reactive web stack in 5. We only really want to maintain 2 web stacks, right? Servlet and Portlet was okay for 10 years. Now Portlet's gone and Reactive is the second web stack that we're investing into, where we see much, much, much more potential than in ongoing support for portlets. Servlet containers, of course, are a specific abstraction in terms of interacting with an HTTP networking stack. We have to remind ourselves that servlets are a specific abstractions with very specific characteristics and to some degree unnatural assumptions baked into the model. They work when unnatural in the sense of not actually matching how the network stacks underneath the covers works, right? But sort of really easy to program against. In that sense, it's a good abstraction. But it is an abstraction that we've kind of grown up with. I mean, I'm talking about myself, right? I started Java web development with the Java Servlet SDK, the thing that preceded Tomcat back in 2000, or even was it, 2000-ish, in the year 2000. So I started thinking along the lines of the servlet model. And I would argue an entire generation of Java enterprise developers started to think along the servlet model. The only way we can imagine coding Java-based web applications, I'm simplifying, of course, right? But in general, the only way that we are considering is the servlet model with its thread per request assumption, there's a thread pool behind an HTTP socket. Every time a request comes in, we grab a thread from that pool, we own that thread, and we're going to process the request, and we're going to spend all the time that it takes to build a response, and until we've written the last byte of the response, we hold on to that thread, and only then we let it go back to the pool. That's basically the servlet model. A CGI-like, if anybody remembers, a CGI-like abstraction where basically an entire process is associated to a particular incoming request. That works well for highly efficient processing arrangements where you don't spend actually much time. Small request payloads, small response payloads, efficient ways of loading data for that response with aggressive optimizations, aggressive use of HTTP caching, aggressive use of application internal caching, very efficient data store access. If all of those things come together nicely, building a highly efficient web stack on a servlet container actually works great, right? There's nothing to complain about. If all of those assumptions actually hold. There are scenarios where servlet stacks have very suboptimal characteristics, in particular under high load. The problem with server containers is largely that it's too easy for the stack to become completely blocked. If the thread pool is exhausted, if all requests are waiting on some external system to respond, and basically all the threads in your Tomcat thread pool are all waiting on something else to happen, then there is literally no thread left to process this extra fresh little HTTP request that comes in. It would be trivial to process that request maybe, but there's simply no thread available to accept it. So the server has to reject it. That's why Java-based web servers tend to reject requests at some point. The infamous messages along the lines of server is busy, too many requests, try again later. Happens quite often these days, and it's often actually Java-based servers that you're getting those messages from. So predictable behavior in extreme scenarios, in high load scenarios, or in unusual scenarios, in high load scenarios, in scenarios where an external system is not reacting as it should, is an issue. And there are ways of getting around it. Of course, I mean, everything's, there's a solution for everything, right? By detecting the inavailability of certain systems, building circuit breakers into your system, there are ways of addressing this. There always are. But at some point you end up wondering whether you would have to re-architect your processing arrangement towards a model that is actually closer to the way that socket programming works, where you're not actually blocking a thread to wait on an external system to respond. Instead, you would come up with a processing pipeline, and whenever that processing pipeline says, I'm ready to process the next step, that's when you're calling it back. If you're currently waiting on something, you just basically park that pipeline somewhere, in a runtime processing stack. It's going to occupy some memory, but it's not going to occupy a thread or block a thread. Anyway, we're going to revisit this I'm going to revisit that line of argument in just a moment. These ideas aren't new. I mean, in the end, they are like everything in IT. They are actually really old. But even in our recent times, in our lifetime, basically in our work lifetime, they are not actually new. There are quite a few stakeholders in the so-called reactive space, right? The reactive manifesto is already a sort of agreement, a common statement by several stakeholders. I'm not a fan of manifestos, really, but the qualities or the characteristics highlighted by the Reactive Manifesto are quite all right. In particular, responsiveness and resiliency are certainly characteristics that we aim for. So from a Spring Framework perspective again, why are we doing a reactive web stack? It's in particular to have a different way of building responsive and resilient web architectures. Instead of trying to tune a servlet stack and kind of do the best we can within the servlet model, we are taking a more radical perspective and saying, like, what if we actually built a reactive HTTP processing architecture where characteristics like responsiveness for newly incoming trivial requests or resiliency against unknown state of third-party systems is kind of a natural part of the story and not something that you have to kind of defend yourself against, right? Where there's a more natural way of handling such scenarios. Beyond the manifesto, which is essentially just a bunch, a couple of sentences and a diagram, there is actually a collaboration initiative called Reactive Streams. This is the part that really got me personally excited about this or interested in this. It's literally reactivestreams.org. A bunch of interfaces living in the org.reactivestreams namespace. It's a collaboration between a couple of people at Lightbend, the RX Java team, the project Reactor group in the Spring ecosystem at Pivotal, and a few others, where we're trying, or where this actually has happened a while ago, right? Where the goal was to model a typical back pressure driven stream interaction. This is pretty low level, right? So it's essentially a step taken towards establishing a sort of ecosystem in the reactive architecture space, where through modeling a core concern of reactive streams processing, we enable a whole ecosystem of HTTP servers, of data stored drivers, of web frameworks, being built on the same reactive streams abstraction to interact with each other underneath the covers. And reactive streams is actually super trivial. I mean, in the end, what it models is a very straightforward arrangement. In the central element are publishers in reactive streams. They are basically processing pipelines being able to deliver data. but instead of those just pumping the data towards some output channel, they don't actually do anything until a subscriber registers. So the publisher is basically just a set of instructions of a data processing pipeline, right? And the moment the subscriber registers, the subscriber may start asking the publisher to send a few chunks of data towards it, as the subscriber is capable of actually processing them, and only once a subscriber is actually registered. So this interaction model, the whole notion of back pressure comes in through the subscriber being in charge of flow control. So things are only happening when the subscriber says that they should be happening. So if the subscriber is an HTTP output channel back to a client, if there's currently network congestion or anything else preventing us from sending further data back to that client, then the subscriber basically just says like, thanks, publisher, don't give me any further data. Only when the network buffers allow for processing further data, the publisher is asked to deliver further data. The publisher may, for example, be a processing pipeline coming out of a Mongo database, right, for certain documents to be streamed to the client, whatever. So this is what Reactive Streams are modeling. Reactive Streams is a key enabler in the puzzle, but it's not actually what you're coding against. This is what libraries and frameworks are based on. So if you are reading about, for example, RxJava 2 or our project Reactor 3 or in our Spring Reactive efforts, they are all based on Reactive Streams. Recent data store drivers are also based on Reactive Streams. Actually, the early reactive data store drivers for Couchbase and for others are RxJava 1 based and don't actually model Reactive Streams and back pressure underneath the covers, but they still do a reasonable job in asynchronous access to the data stores, but they are not fully integrated with this model quite yet. So we, from a Spring Framework perspective, of course, had the benefit of this initiative already having delivered when we started. So we literally started when Reactive Streams went final. And in close collaboration with our Reactor project, our kind of sister project, Reactor 3 and Spring Framework 5 are very closely related. We came up with the idea of investing not only into a web framework, but also into a reactive kernel, which is Project Reactor, and a composition library, which also comes with Project Reactor. In the end, Reactor is a sort of alternative to RxJava. So if you've has anybody been working with RxJava or read an RxJava tutorial maybe? A lot of the knowledge that you got out of this, right? A lot of your understanding of what RxJava does and how to use it very naturally translates onto what we're talking about here. So Project Reactor literally is a sort of tightened up, smaller, more focused version of RxJava. Java 8 baseline, Reactive Streams based, and with only 2 reactive composition types instead of like 7 or whatever RxJava 2 has in the meantime. So RxJava is great, and we actually support it as well if you choose to use it. But our Spring Framework 5 reactive stack is internally based on Reactor, and we always adapt from the types that you're using to Reactor internally. So what does the stack actually look like? There's quite a bit of a potential misunderstanding here. In Spring Framework 5, we actually have 2 web stacks. We already explored that. No portal stack anymore. There's a servlet API stack. The servlet API stack is largely the same way that you know it, right? It still exists in Spring Framework 5. It's actively evolved. It's servlet 4. It's early servlet 4 compatible. It has a few refinements, but it largely is the same stack that you have been using for the past decade, right? In Spring Framework, the Spring Web MVC framework on top is not only servlet API based, it actually embraces the servlet API. You can declare HTTP servlet request and response arguments, HTTP session arguments, or push builder now in servlet 4. In your Spring MVC handler methods, you may choose to interact with the servlet API very directly. We are not trying to hide the servlet API, we let it shine through intentionally. Everything is servlet based, the SPI contracts, the integration with template libraries, everything is servlet API based. This opens a whole ecosystem of third-party libraries out there. We have tiles integration, FileNative integration, of course, FreeMark, all that stuff based on the servlet contract. This remains in place, including all the third-party libraries out there that work with Spring Servlet MVC. And the common way of consuming this, of programming it, on top of this, is, of course, the annotation-based controller model with its request mapping or methods. The traditional Servlet MVC-based controllers. Even if you're not using the Servlet API in your controllers, you can, but you don't have to, right? Even if you don't import any Servlet API artifacts in your controller classes, you actually designed those controllers to run on a servlet-based stack with servlet-based invocation semantics. Your handler methods are actually invoked within a servlet processing thread, owning the request, right, and supposed to produce a response and then return. That's the job of a Spring MVC handler method, of a request mapping method. So that's pretty much the way you know it, right? In parallel to that, in Spring Framework 5, we introduce a completely fresh web stack, which of course has its connection points. It shares a little bit of code, and it shares a lot of design and some common programming patterns with the WebMVC stack, but it essentially is a separate web framework that we call Spring WebFlux. It literally lives in the Spring WebFlux module. Like, you basically choose to use Spring WebMVC or Spring WebFlux. The reactive stack underneath is Reactor-based, Project Reactor-based, Reactive Streams-based. It's an HTTP stack based on, well, a choice of HTTP servers underneath the covers, and using a Reactor HTTP layer on top with Reactive Streams processing. So even if you see names like Tomcat and Jetty appearing down here, don't let that irritate you. Tomcat can be used as a servlet container. Jetty can be used as a servlet container. But what we mean here is that we are using the Tomcat and Jetty HTTP kernel as a reactive web server. Basically, the Servlet API, if it appears at all here, is just an implementation detail for a few details down here. This is not Tomcat in its usual incarnation. It is Tomcat core as a reactive HTTP engine. So we actually have direct support for Tomcat, direct support for Jetty, like native support for Tomcat and Jetty, and native support for Undertow core. In Undertow, that's a little more obvious, since Undertow actually has two distributions, an Undertow core and an Undertow servlet distribution. We are not even using Undertow servlet here. We are talking straight to the Undertow core HTTP server. But the reference probably is Netty, right? Everybody out there building a reactively enabled web framework right now, a web stack right now, seems to use Netty. Like if you look at everyone from well, even Play, Redpack, Vertex in particular, right? They are all Netty-based. Netty is a really rich, extremely capable, very sophisticated networking library. It's probably the most extensive and most capable and most highly tuned networking stack that we have in the entire Java ecosystem. Everybody seems to agree on that. Nobody tries to compete with it at that level. Literally, Netty doesn't have immediate competition for what it's trying to accomplish. And of course, for us, it's a reference model as well. The most efficient, most customizable web stack that you could possibly build with our WebFlux framework is on top of Netty. At the same time, using it on top of Tomcat is a perfectly fine decision. Tomcat is actually a really fine HTTP engine. And there was some active investment into Tomcat to make it more suitable for a reactive web stack. So of course, Tomcat, we have three full-time Tomcat committers at Pivotal, so very close to us, to the Spring team. So this is no coincidence. We even extended the team. We hired Violetta out of the Tomcat community, and she spends most of her time improving Tomcat's reactive story. So she's a committer both on Tomcat and on the Spring 5 web efforts, trying to improve the role of Tomcat there. And this works really, really well. So in the end, we have a choice of those 4 HTTP engines that we have first-class support for. There's actually potential for others to be added to that list behind a reactive HTTP abstraction. But those are the 4 that come out of the box. There's our reactive HTTP layer on top, living in the Spring Web module, and there's the WebFlux framework as the typical way of consuming this stack in parallel to the servlet stack. Now, what's the business up here? We have an annotated controller model for the WebFlux framework, which syntactically looks like a Spring MVC controller, but it really is a reactive web controller. We're going to see that in just a moment. But it's using some stylistic similarity, which actually works out really nicely. As an alternative, there's also a completely different way, syntactically, of using the reactive stack, which are router functions. And both of them are actually best explained by example. So this little thing here looks like a Spring MVC controller initially, doesn't it? I mean, it literally uses the same controller annotation, the same structural arrangement. It's a component class. The component class does typical component things like the dependency injection, the component state. It even has request mapping methods. I mean, in this case, 2 get mapping methods, as Spring MVC in 4.3 would have. If you look a little bit closer, you see that those are not regular Spring MVC controllers. Because in a Spring MVC arrangement, the job of every such handler method is to take the request and process it or return a view for it, right? But in the end, to process it. The purpose of these handler methods seems to be different because they return these strange things here. A mono and a flux, those are 2 incarnations of Reactive Streams publishers. So their job is different. These controllers, such controllers, are actually designed to run on the WebFlux framework on a reactive web stack. For every incoming request, the WebFlux framework is going to dispatch through its mapping predicates to the particular handler method. So if the request/users comes in, we're going to dispatch to this getUsers method. And we're calling the getUsers method to return a processing pipeline for the given request to us. So the job of each such handler method is to build a processing pipeline for the given request, but not actually to process the request, just to give us basically instructions for how to process the request. What we're seeing here is what we're working towards as the common scenario. Those controllers should actually be very thin, very light. Ideally, you would have a repository layer or other delegates underneath that are also reactively designed. So a repository saying like, I want to find all users, a user repository finding all users, but not actually loading the users on the find all invocation, but rather returning a Reactive Streams publisher, which is capable of loading all users once a subscriber tells it to do so. The reactive data store drivers out there for like Mongo, for Couchbase, there are even initiatives for Postgres. They are all capable of working like this. So in an ideal world, and we actually have Spring Data K as a project doing this, we want reactive repositories to delegate to. Wouldn't it be nice if it was always so straightforward? But even if you had to do something different here, reach out to another microservice through a reactive web client and kind of come up with the Reactive Streams publisher for the outcome of that call to that other service, it all ends up with a Reactive Streams publisher that you're returning back to the framework. Now, what is Mono and what is Flux? That's where Reactor comes in. With Project Reactor, we have 2 first-class reactive types, Flux and Mono. Basically, out of the box, very rich Reactive Streams publishers, along the lines of what RxJava has with observable and single. So in the end, you can think observable here and think single or completable here in RxJava terminology. Or in RxJava 2, you could think flowable here. That's actually even closer. Semantically, a flux is a stream of objects, right? So like in RxJava with an observable, it's kind of a hot stream. Like flowable in RxJava 2, it's actually a back pressure enabled stream. But it is a whole sequence of objects that we're going to build when we're actually registering a subscriber for it. Mono semantically is a single object or none. So you could argue, or maybe as a kind of mental hook, you could think Java util optional here. Mono is a sort of reactive version of Java util optional, and Flux is a sort of reactive version of a Java util stream. Sort of. Right? Like any comparison, doesn't really work in the details, but semantically it's quite all right here. So in this reactive stack, this is basically modeling two endpoints. We can actually see that like the extraction of path variables or the access to request headers, to query parameters, to cookies, all of this uses the same syntactic elements that you also use in Spring MVC. There is a strong similarity here. I mean, this is not just another annotation named path variable, it's actually the same annotation as in the Spring MVC model. We are reusing those annotations. Those annotations live in Spring, in the common Spring Web module for a reason. So this is the annotation-based model. And of course, this can be taken to any level, any number of controllers, any number of handler methods, any complexity of handler method signatures. Just remember, the job of those handler methods is to build a processing pipeline. Before we move on to the functional model, and since we have the time, a bit of an illustration for what actually happens at runtime here. These kinds of controllers run with an event loop. So in a reactive web stack, there is no request processing thread pool. There is just an event loop with a thread scheduler and usually a number of requests roughly matching the number of cores available in the system, but not significantly beyond that. This event loop is basically the central hook with the networking stack. So every time something's happening, an event is happening, in the network stack, this event makes it into the event loop, and we dispatch out to a handler for that particular event. So for an HTTP request coming in, a new HTTP request coming in, basically this event loop is where the dispatch is coming from. The event loop says like, yeah, I have a mapping predicate matching this particular HTTP request. Now I'm dispatching to this getUser or this getUsers method here to give me the processing pipeline. We are being called within the event loop. So whatever you do here shouldn't be costly, shouldn't block, by no means do a blocking operation here. This is equivalent to building a user interface and trying to do something extensive in the main rendering event. Yeah? Everything freezes if you're doing this, right? This is sort of related to user interface programming to some degree. It's certainly a commonality, the event loop-based dispatching. So you're only supposed to build a processing pipeline, a bunch of objects basically, very efficiently without actually reaching out to any external system or doing any other blocking operation. And then you return that pipeline. Now it's back in the reactive kernel managing that event loop. That pipeline is now being triggered as data comes in, as the request flows in, as the body of the request flows in. The event loop is going to call to dispatch basically back into the individual processing steps against the scheduler that it uses at runtime. So the runtime representation of this processing architecture is actually very close to how operating systems, network stacks, and even the hardware itself works. Right? We're not trying to use the thread abstraction in Java much at all. We're trying to adapt as closely as possible to the actual concurrent processing capabilities of the underlying, hardware in the end. Because, of course, in the servlet model, you may have a servlet thread pool with 150 threads, but how many threads are you actually going to process in parallel? Limited by the number of cores, right? By the hardware capabilities. Here we're trying to be very close to maximizing the cache locality for each associated thread. There's a whole world of thinking behind why you would want to do this. But it's kind of interesting that from a user programming perspective, you can largely ignore the underlying stack as long as you remember that what you're building here is a processing pipeline. You're not supposed to do blocking operations within the handler methods. You're basically adapting to the capabilities of your runtime stack through a reactive processing pipeline. That sounds easier than it is. I openly admit that programming in this kind of world has its implications. So this is not necessarily a trivial exercise. And showing the functional model exposes you to a little bit more of what it really takes to live and breathe that model. So this is the same endpoints that we're modeling here in the annotation-based world, but with a functional callback model. This is what we call router functions. Actually has two essential components called router functions and handler functions. In a router function essentially says, for certain incoming requests, I have a couple of mapping predicates, and for every matching predicate, I have a handler function that I dispatch to. This is sort of equivalent to the handler method thing that we had before in the controllers with their mapping annotations. It's just that the mapping predicate is programmatically composed, and the handler function that we're dispatching to for processing it is literally a handler function interface, a functional interface, which in Java 8 can refer to an inline lambda expression, or in this case, to a method reference, to a Java 8 method reference. This little example here only works with a couple of static imports. So in case you're wondering, where does the route method come from? It comes from router functions. Oops. It comes from router functions. So there's a router functions and the request predicates static import here, where we get the route methods and the mapping predicates from. But those, well, would just disappear somewhere in the input block. This is the code that you actually would read. So for any incoming request that matches, we dispatch to a handler function. And handler function has a signature of request comes in, and essentially instructions for a response are going out. We are not doing reflective dispatching to annotated methods here. No flexible signatures, right? We're in the functional world. In the functional world, there's a target interface. The target interface has a particular signature, and you have to programmatically code against that signature. No add path variable annotations for extracting path variables. Instead, there's this request argument, this request API type coming in. If you want a path variable parsed out of that request, you need to tell the request to give you a path variable programmatically, right? So what's up with, let's start with the getUsers method. What's up with the method body? We need to produce a response, complete instructions for arriving at an HTTP response for the given request. So let's assume we still have this repository that we can so conveniently delegate to. We call find all. We get a Reactive Streams publisher for a user stream, a flux of users out of it. Now, this is the body, right, of our response. In order to actually produce the response, we need to now say like server response, builder. The builders start with the HTTP status. So OK is basically status, HTTP status OK. We pass in the publisher for the body. And for conversion purposes, because we're not going to send user objects, we're not going to serialize user objects. In this case, this has a Jackson converter registered, where we are partially rendering JSON objects out to the response in order to give it a hint about this conversion. In Java 8, where we have no runtime retention of generics, we have to specify user as a hint for the to be converted type. We can largely ignore this, right? Basically, we're passing in the body publisher here and returning this. So this builder API that we're triggering here actually builds a mono of server response, a Reactive Streams publisher for the response, which contains a Reactive Streams publisher for the body. But all of this is essentially a chain of publishers. So even the response headers are expressed through a Reactive Streams publisher that is only actually invoked and setting and producing those headers when the response is ready to be written. So, I mean, that's the straightforward case. Just to illustrate a little bit more of a programmatic exercise up here, this is not the only way of coding this, and it's a bit naive the way it's coded here, but it does the job, the same job as the method before. So, if we want to produce a publisher for a specific user, we extract the path variable, ID, we start building a Reactive Streams publisher chain, you know, like a mono is a composition type, so like an ArcsJava single or an ArcsJava observable in the general case, or even like a completable future in standard Java terminology, there are composition methods, like do this, then that, take the outcome of this, pass it into that, building a whole pipeline. So in ArcsJava land, if you've seen that before, it should seem familiar. So starting that pipeline with like a just method says basically, let's start with this value that I have already, like the extracted path variable. Let's pass it through a transformation step where we're converting it to a long, assuming that the findById method has a long argument, needs a long ID. So pass it through a long transformation and then pass it into the findById method, and we're referring to it as a Java 8 method reference again. This essentially says like, take the path variable, if you're already converted, then pass it, then call findById with the given argument. And well, that's the body publisher, right? This is just a sequence of transformations basically and invocations that we now have as an object, this mono of user. We're passing it into the body of our response publisher. And that's what we're returning. This is very close to what's actually happening at runtime. This is literally, there's basically no abstraction in between, right? This is the way that the networking stack works, and this is the way that you're coding. So in that sense, it's closer to the metal to some degree. And hopefully at the same time reasonably convenient in what it does. Now, at this model, of course, we chose to have callback methods on a delegate class, and that's generally very recommendable. There's a couple of interesting qualities coming out of this. Now, this code is now on the same page, but it doesn't have to be. A router function can be somewhere in the startup class, like in a Spring Boot 2.0 application class. There could be a router function being in the literal application class, like at the very start of the boot application. Taking a handler delegate as an argument and referring through method references to that handler delegate. There may be any number of delegate methods and any number of delegate classes. Nowhere does it say that there's only a single delegate, right? There could be 10 routes, dispatching to 3 different handler delegates, each with a few methods. Even if you have 10 routes, that's like 10 lines here, right? So that would even scale to, well, could even fill a page with 20, 25 routes very easily and dispatch out to the separate delegate methods. The idea here is that the mapping information is completely independent from the actual handler methods. It doesn't have to live as an annotation on the particular handler method. So you can have a kind of routing DSL at a central point of your service setup. Think about microservices architectures in particular, where there's maybe just 5, 6 endpoints for a particular service. And there's a really nice overview if you have them in a compact form next to each other at a central point of your setup. Right, so there's a strong decoupling between the routing part and the handling part of a request, all in a programmatic fashion. The predicates themselves are a programmatic model. You can implement your own predicates if you want to, or reuse the ones that come with request predicates with the static import that we provide here for the common HTTP cases. Right, and another benefit of this arrangement is it very naturally works with any kind of Java 8 language arrangement. So this is in combination with method references. You could do the very same with inline lambdas. So what if you took the same two endpoints, but instead of choosing to factor out handler methods, delegate methods, we just embed the same code in a lambda expression, right? Because in the end, this routing DSL just needs a handler function. And in the Java 8 language model, implementing the lambda function as an inline lambda, request coming in, response going out, is actually quite nice. There's even the signature disappears, right? With the lambda function in general, you never see the signature of the callback interface. So we don't even see the server request coming in and the server response going out signature at all. Of course, try to scale this, right? I mean, you're not going to scale it very far, but say for the 5 or 6 endpoints that a particular microservice may have, this may, and for very straightforward dispatching to a repository layer where you're only really adding a few HTTP specifics, this may be actually quite nice and even fit on a single screen for an entire microservice. So it's an extremely flexible, highly decomposed, and totally reactive from the ground up model. Obviously, you're only going to use this if the stuff that you need to do can be expressed in a reactive fashion. And the most natural boundary is the data store. So for the purposes of these examples here, I always assume that there's a repository capable of doing it. Of course, you can only implement such a repository if you have a reactive data store driver. That's where our Spring Data project comes in, but we can only do our part if the particular data store offers a driver, a driver with the fundamental capability, or at least asynchronous interaction, ideally back pressure driven interaction. This is true for a number of data stores, but not for traditional enterprise databases. So if you're talking to a traditional SQL database, an Oracle or a DB2 instance, basically, you're going to find out about it pretty quickly that the only way to interact with those drivers is with blocking API calls. In this kind of model, there's no natural way to include blocking API calls. If you want to do this, you need to use patterns like a worker thread pool, where blocking calls are factored off to a worker thread pool, and the outcome of an asynchronous call to that worker thread pool, the future that you get out of this, that's the sort of thing you can build into your processing pipeline again, right? There's always a way out. But simply speaking, this model is to be used in combination with reactive data store drivers and reactive client libraries in general. Then and only then you're going to get the maximum benefit out of this. This unfortunately includes any kind of thread-bound transactions, in case you're wondering about those. So thread-bound transactions, generally resource transactions, are generally closely aligned with blocking data store operations. Reactive data store drivers in general don't have thread-bound transactions or even resource-bound transactions in the traditional sense at all. There are ways of mimicking or identifying a certain sequence of operations. I mean, we're now in data store business, right? But not the traditional thread-bound transaction model. So in simple terms, if you're trying to find out whether you're going to use this stack or that stack, and you're trying to do it from the bottom up, start with the data stores. Can you select reactive data store drivers? That's a strong indication to go this way. Or arguing the other way, are you working with a traditional enterprise database with JDBC or JPA as your primary interaction API? Forget about that stack, right? Stay on the servlet model. That stack is really made for blocking API calls to process a request, right? Then traditional long-running resource transactions stay on that stack, right? There are many reasons to stay on a modern-day, highly efficient servlet stack arrangement. There's really nothing wrong with that. But if you have a reactive data store driver, if you're building a microservice architecture with a high degree of interaction between those services, and you are able to choose a reactive HTTP client library for this, then, and only then, really then, that model starts to shine. That's why we're building this. Don't try to artificially use it, basically. Use it the way it's intended to be used, in combination with reactive drivers and reactive client libraries.
So why to use Java at all?
Why would you do this in Java at all?
Hey, why don't you use it like Node.js?
That's
Something like that.
an excellent point, but that's exactly where, well, basically where the story starts. We assume that you want to do it in Java. We want to enable you to be able to do this in Java, fundamentally in a Node.js style, right? Vertex is trying to do the same thing, kind of bringing a Node.js style model onto the JVM. We are trying to bring a more Spring-minded, more Spring-style model, more enterprise-oriented model maybe onto the JVM for doing the same kind of processing stacks. So we start with the assumption that you want to do it on the JVM, and typically, but not necessarily with Java the language. So to anticipate maybe a related question, doesn't this, or in particular this one here, cry out for Kotlin support? I don't actually have it as a sample here, but yes, it does. We have Kotlin extensions for the router functions DSL, so you can do the same thing with the Kotlin function model as well, which is even a tad nicer than this here. It's also made to be used with functionally designed languages on the JVM. Java 8 as the reference point, but Kotlin kind of as an equally first-class citizen. Couple of further things that I haven't been mentioning yet, or that I haven't been as clear about as I should have been. I was comparing those to like RxJava Observable and RxJava Single. You can literally use RxJava Observable or RxJava 2 Flowable and Single Completable here. Just declare it in your controller signatures. In the annotation-based model, we adapt to what you declare. So the only thing we want from you is a Reactive Streams publisher or something that we can adapt to a Reactive Streams publisher. And we have an adapter registry in place that, of course, naturally handles the reactor types, Flux and Mono. We have out-of-the-box adapters for the RxJava 1 and RxJava 2 types, but it's an extensible model, so even other libraries could be integrated, but I wouldn't recommend that. Use Reactor or RxJava in the end. This is also made to be used with existing code that you're delegating to. If you have the Couchbase driver, the existing one, which is RxJava 1 based, well, you might have repositories that return RxJava observables. Just pass them straight through, or do a couple of transformations and pass them through. So whatever you have that is Reactive Streams capable can be passed to the WebFlux framework and is naturally understood by the framework. You don't have to use Reactor in your application classes. In particular, if what you're delegating to is RxJava based, I would actually recommend staying on RxJava and coding against the RxJava API. Another thing worth mentioning here is that the APIs between Reactor and RxJava 2 are very closely aligned. So the RxJava team and the Reactor team are kind of friends with each other. The amount of time spent on discussing the design between the two is quite an important part of the story. The signatures, the operators, like the whole then signatures, the flat map signatures, all the operators on the Flux and Mono types are almost identical to the operators on the RxJava 2 Flowable type. So if you have a composition chain like here, you could almost replace like Mono with Single or Flux with Flowable, and the code would still compile because the structure of the operators is equivalent. Not necessarily all the callback APIs, but if you express them with lambdas or method references, you don't see the callback APIs. So if they are structurally compatible, the code still compiles. This is, of course, very intentional. They have been collaborating very closely to agree not on a common API type, that's a much harder job, but at least on common operators, common operator naming and common operator structures and common operator semantics. That's already quite some nice value. And the RxJava 2 project lead, David Carnock, even actively recommends reactors. So to quote him, right, if you're building a server-based application on Java 8, then David says use Reactor. The RX Java 2 project lead says use Reactor. Why would he say that, right? Well, RX Java lives under certain constraints. RX Java 2 was trying to be as backwards compatible as possible with RX Java 1. RX Java 1 isn't old, but the 3 years in its lifetime, in its production lifetime, it already accumulated some history, some legacy, you could argue, right? There's some things it cannot get out of. RX Java has a strong user base on Android, so it's Java 6 based. RX Java 2 is still Java 6 based. Doesn't make any assumptions about Java 8 APIs. It works nicely with lambdas and method references, but it doesn't use Java 8 API types. Whereas Reactor is Java 8 based from the start, Reactor 3. So it uses the Java util function types wherever possible, Java util optional wherever possible, right? It's a naturally Java 8 based API arrangement. So Reactor has kind of the benefit of late birth, right? That's it arrived at a time when Java 8 was already established and Reactive Streams the APIs were already established. And of course, it's targeted towards a more specific space. And it doesn't have to be compatible with an earlier version of itself, like in RX Java. So in RX Java 2, they did a fine job, given their history and given their constraints. But they could only take it so far. Reactor is kind of RX Java 2, but from scratch, server-oriented Java 8 baseline, and like half the size. Of course, so it's also in terms of the size of the library, there's also quite a difference. Anyway, but it's essentially your choice. If there is existing RX Java code or existing RX Java know-how, existing RX Java preference, you're completely free to use it in the annotation-based model. So that's a benefit of the annotation-based model. We can reflectively adapt to your signatures. Whereas, of course, in the callback-based model, the interface type says, I want a mono of server response. So you have to return the Reactor monotype. You can adapt an RX Java 2 single. So if you had a single here, if the repository returned, or a flowable, if it returned an RX Java type to you, you can adapt it rather easily. Some signatures we even opened up to the degree where you don't have to adapt. You can pass any Reactive Streams publisher into the body method. So even if this was an RX Java type, we still understand that's a Reactive Streams publisher for the body. But you're going to have some Reactor imports in your code, right? Because ultimately the uppermost processing pipeline has to be a Reactor type in this model. So that's our general story for this Reactor versus RX Java, the whole API debate. We're doing the best we can to enable the use of RX Java 1 or 2. Actually, we prefer 2, but 1 is just more common out there. There's a lot of code, quite a few drivers that are RX Java 1 based, so that's why we're even bothering with both generations of RX Java. Yeah, that was all I meant to add here. And that's basically all I meant to say about the Reactive story in general. So there was quite a bit of ground that we covered here. We talked about JDK9 and Jigsaw. There's even a cross-reference back from the Reactive story to JDK9. This is kind of a bonus topic, though. So I'm perfectly happy if you ignore it, because I don't think it's that practically relevant, but it's still a nice endorsement. I'm talking about Java util concurrent flow. So in JDK9, they chose to repackage the Reactive Streams APIs, publisher, subscriber, subscription, into a type called Java util concurrent flow in the Java util concurrent package. So they kind of embraced the Reactive Streams abstraction. The problem is, nobody actually uses those API types. Everybody uses the org Reactive Streams version of those types. They are identical. They're completely the same interfaces, just living in a different package. And at this point, the repackaging in JDK9 is kind of nice, but irrelevant. Because all the drivers, all the composition libraries, all the web frameworks, they are all based on the org Reactive Streams version of those interfaces. But it's still a kind of nice endorsement. Doug Lee, the maintainer of Java Util Concurrent, basically says that this is an aspect not modeled by any other types in Java Util Concurrent, the whole hot stream back pressure driven flow control. So he chose to at least have a version of the interfaces in JDK9 for future generations of frameworks to possibly be based on those instead of the org Reactive Streams version. At this point, I'm not aware of anyone using the JDK9 flow. Not even products coming out of Oracle themselves, because they're all JDK8 based. So they all have to use a copy of the APIs or the org Reactive Streams version of the APIs. In practice, it doesn't make a difference to you. You're not coding against those anyway. You're coding against RxJava or Reactor or any other library at that level. Whether they are internally based on org Reactive Streams or on the JDK9 flow type is actually irrelevant. I mean, if it blows up at runtime because they are using the wrong version of the API, then you're going to find out. But from a programming model perspective, it's not the case anyway. Everybody's based on org Reactive Streams. It's not going to blow up right now. But in a transitionary period at some future point, that could happen, right? How are we handling that? We actually understand the Java Util Concurrent flow types as well. So if you pass a Java Util Concurrent flow publisher to the Webflux framework, it knows what to do with it. It adapts it to a Reactive Streams publisher. So we understand those, but that's kind of an exercise. So we implemented that, but we don't know of a single implementation of a Java Util Concurrent flow publisher. We just expect them to materialize at some future point of time. And we baked it into the framework already to be ready for it. Anyway, so there's even a connection between the Reactive Streams model and JDK9 again. The HTTP2 story, the ALPN stack is of course a JDK9 topic in its own right, and we've seen that in the reactive space, the whole functional endpoint registration model, router functions and handler functions are actually a really appropriate representation of what you intend to do as an alternative to the annotation-based model. So those themes are actually all connected one way or the other. All right, so to wrap up, we are going to do an RC1 next. We do not intend to do a further milestone. There's M5 out rather recently, 5.0 M5. We're aiming for a first release candidate in late April at this point. And that's pretty date-driven. So in the end, this is going to happen in late April with whatever we have by then. So everything I've been talking about today is already in M5. There's a little bit of fine-tuning that's coming in RC1, but nothing that would be relevant to today's story. So the JDK8 baseline, the JDK9 Servlet 4 support, the early support for those, the Kotlin support, the entire Webflux framework with both usage models and all of the 4 supported containers, it's all in M5 already. And with RC1, it reaches a feature completion point, of course. We intend to upgrade to the latest possible where we can. Kotlin 1.1 already happened. Reactor intends to do a 3.1 in time for our 5.0 release still. So we're at the time that we go RC1 here, it's going to be based on the very latest incarnations of all the libraries that we are integrating with, optionally integrating with here. I've hinted at Spring Data K, which is not a Spring Framework concern. We let you interact with any kind of repository of your own. But we actually have a repository model in our Spring Data project that's traditionally, of course, synchronous, right? Blocking repository calls. In Spring Data K, they have a Spring Framework 5.0 based version of Spring Data where they introduce a reactive repository model, which is basically Spring Data repositories with signatures that return Reactive Streams publishers. And Spring Data at runtime substituting those methods against reactive data store drivers. This is an important part of the overall story, but of course not the only way to implement repositories. In particular with custom, like microservice architectures, you might have very special requirements in what you exactly do with your repositories. But if the model works for you, and for common cases, it is a very convenient model, then Spring Data K does everything it can against Mongo, Cassandra, Redis, and Couchbase is still at least planned in its initial Spring Data K revision, which is going to come soon after our 5.0 RC1. It's going to be in release candidate mode itself. This is only the beginning now of a story. In Spring Framework 5.0, that's already true. We see this as kind of a first fundamental step to take, and we're going to complete the picture with 5.1, 5.2 releases over the next few years. It's even more true in Spring Data Land. They are going to embrace reactive data store drivers as they appear, as they're actually being released in proper form. With the initial K release, I'm pretty sure that they have to wrap up now, but there are more reactive drivers coming every year or so at least, right? We're trying to do our part to motivate the vendors there to finally ship reactive drivers. I mean, it's kind of all connected. The dynamics in the open source ecosystem are quite interesting here, and everybody seems to kind of wait for somebody else to do their job first. On our end, we really see this as an enabling step for the entire ecosystem. So in all likelihood, some of the data store vendors see our Spring 5 efforts as a motivation why they would finally ship productized versions of their reactive drivers. I really hope that's happening. Some of them already did it. For some of them, I wish that they would revise them and do a more modernized version, Reactive Streams-based version of those drivers. There are plans for many things, but a plan only goes so far. I want to see those things happening. And this may not happen in time for our releases in June, but it certainly will materialize over the next year or two, and we will pick up those reactive drivers as they... Spring Data does revisions every 8, 9, 10 months, so there's always a next Spring Data release train to pick up a new driver. And the end of our chain of releases is Spring Boot 2.0. This will only start with milestones. I mean, there's quite a bit of Spring Boot 2.0 usage out there. I mean, funnily enough, but they're all using snapshots. We haven't actually done a regular milestone yet. This has to happen. It will happen very soon. So there's a whole sequence of milestones coming along with our release candidates. This is a very important part of the story. Now, the Spring Boot is such an important entry point, not only to Spring Framework itself, but to the other portfolio projects, to Spring Data and co. So in Spring Boot 2.0, when they're doing the obvious, right? It's 5.0 baseline, Java 8 a requirement now. It has upgraded dependencies. That's the hardest part in Spring Boot 2.0 is actually the dependency arrangement. Since part of Spring Boot's mission is to have a kind of well-tested, well-defined dependency arrangement that it ships. It's tough, right, with the reactive data store drivers and everything. And it of course has a first-class story for reactive web stacks. So you can opt into the reactive version of a web stack, or you can run boot, of course, in its servlet-based incarnation. It's quite nice already. If you want to play with this, go to start.spring.io, choose the Spring Web Reactive Starter, and just take it from there. You're going to get a Spring Boot 2.0 snapshot. Ignore that for the time being. It's going to be a milestone one soon. But it actually works quite nicely, even with the snapshots.
Will there be an option to have both on only one application, Reactive Way and Server Way? I mean, no like...
Yeah, like a server container and a reactive web stack. In Boot 2.0, they are explicitly making this an either-or decision at the moment. So you have to do one or the other. In practice, I strongly recommend that. Because if you run a server container, and even if it's Tomcat in both cases, right? Tomcat as a server container and Tomcat as a reactive HTTP engine at the same time, you have parallel infrastructure. A servlet request thread pool, completely isolated here, and an event loop scheduler with its own thread pool over here, which kind of sit next to each other and eat each other's operating system resources, right? So both with the networking stack and with the threading arrangement, they are competing for system resources. That's a situation you do not want to have in the reactive stack at all, right? So it technically can work, but you're not going to get the benefit that you want out of this. I strongly recommend decomposition. Right? In a microservice architecture, use the servlet stack in one microservice and use the reactive stack in the other. As long as they have kind of, even in a container arrangement, if they run in isolated containers with isolated operating system resources, that can work nicely and you can tune it independently. But within the same JVM, you're basically out of luck. Right? They're going to compete at too many levels there. So I'm very much in favor of mixing and matching per microservice or per service, per part of the system. So if you just want to do a few reactive endpoints, consider factoring out a separate service arrangement, maybe that does the demanding jobs that you want to model reactively as a separate microservice, maybe. I would strongly recommend that. The final word hasn't been spoken there yet. Maybe we're going to be a bit more pragmatic but we're not actively recommending the combination for sure, even if it's technically possible. I understand the desire, though. It would be nice, but it's just generally not that good an idea. All right, any other questions that we haven't been touching upon before?
I have a question.
Sure.
What do you think is the typical applications or the implementations needs of what would you use for
The reactive stack in particular now?
Like video server or
Yeah, it's there's that's a key question, of course, but it's actually tough to have a simple answer for. There's a whole camp out there saying the most natural way to implement reactive web endpoints on the server side, is in the reactive stack. So you should use it by default, basically. That's one camp. I'm not necessarily in that camp. I would rather argue that if the serverless container world works fine for you, make sure that you properly tune it and get the most out of that for a start. But there are certain scenarios, certain interaction models that servlet containers are just inherently not ideal for, right? Not incompatible with, but not particularly well suited. It starts with any kind of longer request interactions, right? Server-sent events, for example, is you can do server-sent events like as in the HTML5 SSE model. You can do that in a server container, but if you look at what you're doing there, like binding to a separate thread that kind of sets event results into that other object that lives within the servlet container thread, it's a little unnatural. Implementing server-sent events in the reactive model is so straightforward. To me, that was kind of an eye-opener. Implementing a server-sent event architecture with the reactive model is really, it's so natural that since you just have a publisher and every time that publisher produces a piece of data, the server-sent event model renders out a data entry to the client and doesn't consume any resources in between. Implementing this in the reactive model is very natural. Any kind of longer running downloads, like document servers of any kind, that sort of thing really benefits from a reactive interaction model because it's network congestion. What if you're somewhere along the lines of the download 90% and the remaining 10% just hang for an unknown reason? You're blocking a thread. There are ways out of this in the servlet world with the async model, but the async request processing model that we also support in Spring Servlet MVC, it's not particularly nice to code against, and it only works for some specific purposes. You can only park a request and based on a signal kind of reactivate the request. It's not a particularly natural model to code against. So it's somewhere in between there. There's a line. Beyond that line, the reactive model is actually more natural for implementing what you intend to implement. Whereas in a traditional REST endpoint model with strong HTTP-based caching, e-tags all over the place, and everything efficiently tuned, where everything's in memory or a local data grid that you very efficiently get the data from without reaching out to another machine's networking stack. That works really nicely in the servlet model. You can code this reactively, of course, but you won't actually see much benefit. If your request processing is so efficient that you hardly ever block anyway, because you're talking to highly efficient concurrent data structures with local caches, you're not going to see much difference. The utilization of your operating system and your networking resources is going to be at a very similar level between those two. Reactive is not necessarily faster. I mean, it's not meant to be faster anyway. It produces different runtime characteristics, which may matter in some scenarios, but it totally does not make a difference in many other scenarios. So it's actually a really tough question to answer. Personally, I would just, if you're interested in it, I would recommend to familiarize yourselves a little so that you understand how this model actually works. Try to implement a simple little thing with it. Try to burn your fingers several times to understand the constraints, and that it actually is to some degree hard to do right. It's not trivial. It's not I would even argue that other characteristics may matter more. Right? Are you working with a large developer team? Is that developer team familiar with reactive programming? If not, stay on the servlet model, right? So if in a microservices, more DevOpsy arrangement where you have independent ownership of a particular service and the 3 developers working on that service say, we want to code this reactively and we know what we're doing, let them do it, right? So there may be completely different concerns coming in, not really technical. That's the reason why we ship them in parallel, right? If you don't feel the need to implement a reactive web architecture, you probably don't have to, right? It's as simple as that. We are not Lightband. We are not saying everything has to be reactively and working with Cassandra and doing event sourcing, which is basically what Lightband says in Legom. We are super pragmatic about it, right? Understand what you actually need to do, where the real bottlenecks are, how actively the code needs to change as well, and who's going to work on it, and make a reasonable decision on that basis. That's all I can recommend, really.
Okay.
All right.
If you don't mind.
Yeah, we've been going on for a long time in the meantime.
let's continue with the questions and answers.
Yeah, I'm happy to have one-on-one conversations.
And drinks.
I also need a drink now in the meantime, yeah.
Thank you very much.
Yeah, thanks for your attention for a start.
There is a lot of food and drinks out there. It's all for you. I hope you will stay with us for a while.
Oh, yeah, of course.
Okay, so feel free to ask Juergen anything you want. Feel free to walk around the offices. Feel free to drink anything you find.
I'll take your word.
Okay, thank you guys. Thank you very much.
Yeah. All right, cheers.